Hello.
Hi. Hello, Chad. Hello, Demi. Hello, Megu. As soon as we start stream, my birds are yelling. This is insane.
They want to learn too.
Yeah, they're really excited about math.
I noticed you click the go live button. It's time to interact.
Yes. They always do this. I don't know how they know. I don't know how they know. It's like the entire loading screen, they did nothing, and then I switch screens, and then they start screaming for a minute. It's unreal.
I'm gonna draw some doodles.
Some doodles. What to
Doodles.
doodle? Ah, I can't move. Wait. Which button was it? Why is it not working? Okay. I'm gonna have to use my keyboard.
You have to use your keyboard.
Dude, no, wait. Why is the space... Now it's working. Why did my space bar not work? I wanted to move downwards. It's fine. Oh.
So,
Sensei.
Megu's already done with the lesson.
Yes. Lesson's over. Thanks for...
Lesson's over. Everybody go home.
Yeah.
Class dismissed.
Class dismissed. Goodbye.
Thanks for coming. Oh boy. Okay, yeah. Math time.
Yeah.
I wanted to do a little bit of a refresher for us. Both
Uh-huh.
for myself as well. It's been forever since I actually sat down and looked at math properly, even though I really like math.
Mm-hmm.
Yeah, I don't know. We had some funny math, how do I want to say? Math situations with Leighton in the past couple of weeks when you streamed Leighton.
I don't remember any of that. What are you...
You don't remember any of that?
Nah, what are you talking about?
Gremlin mode activated.
I don't know what you mean. Okay, keep going.
Thankfully, I hope that my lesson here is a little bit less of trick questions than classic Leighton examples.
I hope so too. But also, it would be a challenge. Just throw in a few latent questions.
I did look at I did search for Professor Layton puzzles, math puzzles, and looked at some kind of like archive of them somebody has on a wiki online, and I was gonna like sneak some of them in as like little trick questions, but I thought no. No.
I see.
It'd be a little bit too mean for a first lesson.
For a second lesson then. Sneaking in some latent. Okay, so
yeah, let's I guess I'll move slightly down the board. Give me my cursor. I'll move over here somewhere. I'll just hop right into it, I guess.
Okay.
Feel free to interrupt me at any time.
Okay.
If anything is. We're gonna start out really basic. And we'll go from there. We'll see what we can manage. Drawing is good. Drawing is good. So we're gonna start off with the most important part of math at all.
Numbers.
Orders of operations. Numbers is also a good thing. It's good to identify what is a number.
Yes.
What is a number?
What is a number? Is there a definition for what a number? It's a visual representation of an amount.
Amazingly, you first learn stuff like that in like higher level university class, because everything that you ever learned about math up until then is like completely thrown out the window.
Yeah.
It's super advanced stuff.
It's insane. How the higher up you go, I feel like when you return to basic math, it's just hell. We're
gonna stick with the easy stuff for today, I guess.
I had a math teacher and he made us prove that 1 + 1 is 2, and I had
Oh
like an
my
entire
gosh.
page of stuff that I don't
Yeah.
remember. So
Amazingly, I was one of the only students in my class that actually enjoyed proofs. Everybody else hated it and they made fun of me for it.
proofs are fun. I had it with a different teacher before, and I really enjoyed it. But that teacher just really wasn't good at explaining it. I don't think anyone got it, and it only passed because I already knew what it was.
Yeah, that's really unfortunate.
Mm.
That's why I definitely want to have these kind of like learning sessions open for anybody to just raise their hand and say, "Hey, you explained that terribly. Can you try again?" And then I'm happy to try again.
Okay.
Yeah. Order of operations. Yeah, I'm going to explain how I learned it from my country, and then you can explain the differences how you learned it in your country, because I'm more than sure that these acronyms are going to be different.
Okay.
Or maybe they won't be, I don't know. We have this concept of order of operations, whereby when you have a mathematical equation, you need to solve certain portions of this equation in the correct order in order to get to the correct answer. The acronym that I always learned for this was PEMDAS. And what this stood for us was, please excuse my dear Aunt Sally. I looked up on Wikipedia actually before the stream of different acronyms for this, and yeah, they're different between a whole bunch of different countries, but generally use the same letters or so. And this right here will be for, yeah, parentheses rather, exponents, multiplication, ooh, division, addition. Well, that's too many T's. Ow, I just hit my desk.
Ouch.
And subtraction. One important part to note about order of operations is that multiplication and division are basically the same thing, just inverses of each other, and same with addition and subtraction. So as we get into equations and we start doing them, multiplication and division, they have the same precedence, the same order of precedence. Same with addition and subtraction. And that means that we solve those from left to right, rather than having them be a priority over the other rules yeah, within their group.
Makes sense. I never learned a funny little PEMDAS.
You never had a little...
No.
You never had a little...
I was just supposed to memorize it.
Just plain memorize it?
Yeah, it was just like, yeah, you first do the multiplication. Wait, no, we had a... We had a thing that's like Punkt vor Strich, dots before lines, which basically means like, oh, the multiplication and division stuff for the addition and subtraction stuff. But that's all.
Lines. That's an interesting concept. Huh. That kind of feels like there's edge cases in there waiting to trick you if you
Yes.
really take it at face value.
Yes. I think it's because division is that and times is that, and those are lines. So
that symbol.
It's the dots before you do the lines.
This symbol right here is a really dangerous one.
I know.
Exactly that guy. We'll get into the reason why that guy is dangerous. That guy causes a lot of problems. There's a particular change in how mathematics was generally performed, I guess you could say, around 1917. And afterwards, that symbol does different things than it used to, which is what causes a lot of the memes online.
Mm.
Let me grab my notes. Yeah, and the second thing that we want to take a look at, which is another kind of good base for knowledge here,
Uh-huh.
is negative numbers.
Uh-huh.
So negative numbers, yeah, when you play with negative numbers together, when you add them, multiply them, divide them, subtract them, depending on the polarity of each of the numbers involved, yeah, you'll have a particular polarity come out. Meaning, if you, for example, if you're adding a negative, that's like you're subtracting. And yes, this is very basic stuff. I wouldn't expect that you don't know any of this, but
Okay,
just for ground rules.
Yep. Oh yeah, exponents are 2 squared, Megu. Yes, it's the little number, the tiny number on top.
Thank you for the follow, Megu. Now you can watch in 2 perspectives at the same time all the funny things that we're going to do.
All the fun adventures.
Fun adventures, if you want to call them that way. So adding and subtracting here, generally fairly simple. I will write a little reminder for multiplication and division, just so we have it. So a negative times a negative, is that readable? Probably not. Equals a positive. If we have a negative times a positive, that's a negative. And now we have this dangerous symbol here. A negative divided by a negative, going to be positive. And a positive divided by a negative, going to be negative. So these kind of like act as inverses of each other. That's why I say multiplication and division are pretty much the same thing. They're just inverses. There's some tricks that you can do later on with percentages and probabilities and calculation and that effect, especially with fractions, where if you need to do the opposite of multiplication or division, you can just swap the operator and do it a different way, and then you get to the right answer that way. But that's for afterwards. So, yeah, we're gonna jump directly into some equations here. I'll give you a couple of beginner exercises that we can start with, and then yeah, if there's any questions that come up during them, then we can explain it and talk about it and all of that good stuff.
Now we gotta learn integrals. Oh god.
1 to the power of 1 plus 2 to the power of 1 plus 3 to the power of 2 equals... Go for it.
Okay. Do I like just write the answer, or do I tell my path?
You can show your path if you want. For the later stuff, you're gonna have to show your path, but for these guys, we're just practicing with order of operations and stuff. So if you have it just in the top of your head, go for it.
I really enjoy my chat being confused in that.
Let me go check your chat. What's going on?
What the math?
Math? Why are we doing math today? Where's the rhythm games?
Where's the rhythm game?
I didn't sign up for this.
But 3 squared is 3 times 3, right? So it's 9 plus 2 is 11 plus 1 is 12.
Perfect. Good job.
Yay! So I get a golden star now.
One done. I actually do have a gold star emoji in my Discord. Hang on, I read it to you in Discord. Hang on. There's your first gold star.
Let's go! I got a gold star! It's my first one.
I hope you have a collection of these by the time we're done.
Let's go. I'm gonna stick them in my album that does not exist yet.
I like the idea of that, a gold star album. 3 to the power of 3 minus 2 to the power of 2 equals.
Okay, now we're doing math.
Now we're doing math.
Now we're doing math. Okay.
This is also a little bit for me like, how do I want to say? Kind of like an evaluation.
Okay. 9, 8. Okay, that's 27 minus 2 times 2 is 4. I hate adding and subtracting stuff to 7, by the way. I never looked. I can any other number, but
You're so close. You're so
that's
close.
23. That's 23. I think.
Yes. Let's go. Okay. You ready to kick it up a notch?
Yes, okay, yes.
I hope that one was okay for you, because now we've got -5 times 7. A little line in there. Plus 9 times 5 over 5 equals.
Okay, so 9 times 1 is 9. That negative 35 plus 35 minus 9. Wait, that's minus. Wait. This is a guess. Is my brain braining?
You've got it. Your brain has brained.
My brain. I forgot all the numbers in the second half of my calculator in my head.
That's okay.
And then I
There's only
panicked.
10 numbers. 0 through 9. Those are the only numbers you have to remember. Okay, the next one. Now we're going to start mixing in some exponents.
Okay.
We've got -8 minus the sum of -2 plus 7
All the 7s.
squared.
All the 7s.
I'm writing uphill. I think I need to tilt my drawing tablet.
Okay, no, the 5! Help the 5, the -5. Dead. Okay. Okay. -2 plus 7 is the same as 7 minus 2, so it's 5. 5 squared is 5 times 5 is 25. So we have a negative. Wait, I need to write that. We have a -8 minus 25. And now that's the difficult part right here. That's
The last step.
That's -33.
Let's go!
Yeah!
Nice! You've got this. You can do it.
I love how the thing I struggle the most is basic addition.
I should have prepared more addition and subtraction. I went all complicated. I thought Bettery is gonna know all of this. I've got to make it difficult.
My brain do be surprising. I'm surprised that you're actually getting these right. I can do math. Fine. It's fine. These are just numbers. Oh god.
-7 plus 63 ninths.
Ah! Okay, wait. 9, 18, 27, 36, 45. I'm not even saying the numbers in the right order. In Germany, we swap the numbers. If I say stupid stuff,
Yeah, no worries.
then
no
it's because
worries.
I'm thinking German. Alright,
Yeah, I thought that might be a little bit difficult here between native languages and all.
I forgot where it was. Okay, wait. 9, 18, 20. 36, 45, 54, 63. That's 1, 2, 3, 4, 5, 6, 7. That's 0.
There you go.
Yeah! Oh.
There's my pen. An easier way to see this guy right here is to imagine if that 9 was a 10 instead, then 10 by 7, 10 multiplied by 7 would equal 70. And then if you're just subtracting one of the 7s from here, 70 to 63, that tells you that it's the 10 multiplication table down to the 9 multiplication table.
Okay.
That's probably that might just be how my brain works instead, which is also perfectly fine.
I can kind of see that, but also
There's a lot of those things in math actually where it's like there's more than one way to the right answer, and different people's brains are going to think about it a different way. Actually, a lot of the primary school education these days over in the States is doing a lot of that kind of mental math. Like you'll see a lot of memes online where a parent will get their child's homework, after school and all of that, and they'll look at it and they'll post it on social media and say, what are they even asking my child? I can't even understand this basic math.
Yeah.
Because they're teaching a completely different mental model of how to rearrange number these days. It's like if you have something like, I don't know, like 43 plus 17, right? One of the mental models that they're having kids think about these days is basically add the ones first. So you have 3 plus 7 equals 10. They call it counting tens. And then you end up with 40 plus 10 plus 10.
Is that not what people just do?
Some of them yes, some of them no. I don't know.
I don't know.
I mean, it's what I do at least.
I think that's what I also do, because we used to write it down like this, right? And then we would add the 3 and the 7, and then we have a 10,
Right.
and then that's the same thing.
Oh, interesting. You put your little carry number on the bottom.
You put your little carry number there.
We always put it up here.
I had both. I went to a bilingual school, and my American teachers always put it on the top, and all my other teachers put it on the bottom.
That's gotta be heck.
I mean,
What
it's
the
fine. They're
heck?
just the tiny carry numbers, you know? It's not important where they are. You just need to know.
Also, I noticed that you don't put the little thingy on your one. I mean, sometimes I've seen people here like write their ones like that. The first time I saw that, I said, "What the heck is that? Is that an A without the line in it?"
I either do that or that.
The two extremes.
Two extremes.
Oh my gosh.
Okay,
I mean,
those are my only two ones. It's either the one or the other. I don't do normal ones.
as long as everybody
Actually-
knows that you cross your 7s, I guess it's okay.
Do people really write them like that? I feel like I didn't write it like that since primary school.
I do. I mean, if I'm going to write it like this kind of wider version, if I'm writing it in a German context, I actually write it. I've been called out for this. I don't write it like that. I write it starting from the other side. I write it like that.
Huh?
Yeah.
It always confuses me when people write like numbers or letters the wrong way around.
Right?
It's like I saw someone write a 9 like from the bottom up, and it's like, huh?
Oh my gosh.
Huh? What the? Who does that?
That feels so weird to do.
Yeah, who does that?
Or like an 8 with 2 circles.
Oh my god, I hate that. Oh.
You don't have a nice curve in there anymore. Oh, that looks so terrible.
A nice curve in there.
Erase that immediately. Hide my shame.
That was a beautiful curve.
Don't look at it. It's gonna be in the VOD forever. Okay, let's give you the next example.
Okay. I like how we're going like not straight down, but like we're going diagonal.
Yeah, I'm. My brain is on a curve today. I guess I don't know.
It's fine. Just looks
Okay,
like
what
my
do
map
we have for
folder. It's
nine?
okay. My
We've
9 is more
got-
like a G. That's the normal way to write a 9.
-12 over
Oh god.
-4 minus 8.
Oh no! Okay, this is fine. This is fine. I can pretend I know what I'm doing, right?
Pretend away.
I'm gonna pretend I know what I'm doing here.
Yeah, exactly.
I don't. Minus -4. So that's 12. Oh, that's just 1. Is it 1
There
or
you go.
-1?
It's just 1.
It's just 1.
Because you have the top of your equation there, the top of your fraction matching the bottom of the
Oh,
fraction, and you're saying you've completed.
I remember
Yeah,
this
exactly.
crossing thing. Yeah, I remember crossing stuff
Yeah,
out.
yeah. The negative gets simplified away, and then you have 12 over 12, and that's just one whole piece.
I see, I see. Thank you for the head pad.
-2 to the power of 3 minus 3 to the power of 2.
To the power of. Is that how you say it in English?
Yeah, how do you say it?
We just say 2 high 3.
You call it high.
Yeah, we just say,
mean,
oh, it's a high 3. It's...
I guess it's up there.
Yeah, just up there, you know? It's just high up in the sky.
So like, if you've got a happy face, and there's a 5 up there, and that's a high 5.
And you... I guess it is, yeah.
Oh, even I'm face
five.
palming at myself.
Okay.
It's terrible.
Cultural exchange here. This is quality.
This is perfect. I'm learning so much here.
I'm also learning. Okay, now that's -2 times -2 times -2. 2. That's 8. -8, right? -8. Okay, and then we have +9. That equals 1.
Not quite.
Ah. Wait. We have -2 times -2 times -2. And these cross out, so yeah, the first one is still negative, right? Yeah. 2 times 2
The
is
first
4.
one will be negative, yeah.
Yeah, 2 times 2 is 4. Times 2 is 8. And then we have -3 times -3. 3 times 3 is 9. We almost did negative, so it's plus. Okay, 9. Right? And that's... Yeah, 9 minus 8 is 1. If it's wrong, then I don't know.
Hang on, I'm actually second guessing myself now.
I bested the teacher. I won math class.
There's going to be plenty of times where I'm getting confused here too. What's funny though, right, is I've done all of these equations and double checked them as I prepared them. And I have everything written down. So I'm just checking my notes here. I see why. Yeah, exactly. So one way to think about this equation, let me grab this guy, is, oh, let me tilt this as well. If we have the negative 2 to the power of 3 minus 3 power of 2, we get the correct answer if we're actually solving the exponents first. From order of operations.
Yeah. Yeah, okay.
And so when we do 3 times 3, wait, am I going to come up to the same thing here? We've got 9.
Yeah, that's 9.
2 by 2 by 2
It's 8.
is 8. Minus 8 minus 9. Yeah, exactly.
Yeah,
2 by
okay.
2 by 2 is
Okay.
8. And so we have minus 8 minus 9.
I see. That makes sense.
So you had me second guessing myself there for a moment. I'm like, wait a second, what went wrong? Where are we? Where did we go? I had it written.
It made sense.
It did make sense enough that you confused me with it. So when we have minus 8 minus 9, we've got minus 17.
I see. Oh my god.
It's okay, we're gonna have a funny one like that in a moment again.
Oh, let's go.
Nice.
But now I know the trick.
Okay, let's do something with some bigger numbers.
Oh no, okay.
We've got 2
Mhm.
multiplied by 10 to the power of 4 minus 7 to the power of 3 equals. Feel free to write scribbles because we're gonna have big numbers.
Okay. So 7 times 7 is 14. 14 times 7, what the... Okay. 14 times 7. 7 times 4 is 7, 14, 28. Plus 7 times 10 is 70. Am I doing this right?
Might be easier if you
And then I
have it in like this
98.
tall notation.
Did I mess up? Alright, so then we're still 28. Oh, and then like that.
How are you finishing this equation before I answer?
And then we add these numbers. I'm doing this wrong. That's a high number.
728 is a bit too much.
Yeah, a little bit. Was I right before? Was I right before that? If so, then why did you... Is it 98? Was I right before this?
It is 98. Was what 98 what you had before?
Yeah.
Okay, I was not paying attention to your extended one there, and I wanted to see you do it vertical.
I see. No,
I
just made horizontally the same thing, and then I thought I made a mistake.
Oh, no.
It's like, oh, no,
I just wanted you to write it in the other way. 728 though, that would have been a little bit much.
Yeah, I was like, huh? What? That's a lot. That's a lot. Okay. And then we have 10 times... Okay, 10 times 10 times 10 times 10. That's 1, 2, 3, 4 zeros. So that's 10,000. That's a high number.
That's a big number.
That is a very big number. Okay, 2 times 10,000 is 20,000.
Mm-hmm.
And then we have... I'm sorry for writing my notes everywhere. without context. 20,000 minus 98. Which is... Okay, wait. No. That's 2. Wait. Is that the answer?
That is unfortunately not the answer. You made a problem much earlier in the equation, actually.
Oh. Yeah, understandable.
So you've got this guy fine,
Uh-huh.
but how did we get to the 14 by 7?
Oh, wait. Yeah, 7, 14. Yeah, this thing.
What is 7 cubed? What is 7 to the power of 3? Can you write it out in full form?
Yeah, okay, I know, it's 49. I feel so dumb right now. Okay, never mind any of this. This did not happen. There's no proof. Okay, my brain. I know what 7 times 7 is. I didn't realize it either. Thank you, Megu.
Oh, Megu's giving you the answers? Oh, I'm going to look at your chat.
No, wait. Oh yeah, I'm not looking at the answer. And then okay, that is a very high number though. 70 minus 7 is 63. Wait, like that. And then 7 times 4 is 28. That's a very high number.
It's a big number.
It's a very big number. Um... 343?
343 is correct.
Let's go! Okay, so we have...
Nice.
We still have 20,000.
Mm-hmm.
Minus 343. That's 7, that's 6, that's 7, and those are still 20. 20,767!
Ooh, something a little bit wrong with the subtraction there. Close. Very close.
Okay. I can still fix this. I can... Oh, it's because it's 10, right? I forgot about the ones. So we still have 7 here, and then we have to just subtract 5. 6.
There you go.
Yay!
19657.
If that was wrong again, I would cry.
That's the danger with working with large numbers.
I know how to...
One little trip up and it's going to completely mess up the
Yeah.
whole rest of the equation.
I totally know subtraction, yeah, no. Easy. That's a 9.
We can call it a 9, if we must.
I'm sorry my handwriting is bad.
I mean, did you... It almost looks like you did one of those start from the bottom things.
No,
Like a little-
it's because my pen doesn't... I'm writing so fast, the platform is not realizing
That's a
I'm
letter
writing
G.
until the middle.
That's a letter G. That's how you spell good job.
Is that not how you write a 9? I write it like a G, yeah. That's how you write a 9. How are you
I
writing
mean-
9s, huh? Nah.
Like that. They're kind of like a music note. You put a little curly do on them.
That's just a merit P. That looks like a
Letter
Q. This is a Q.
letter P.
This is a
The
Q. I'm
Q
writing.
has a little.
This is
The
how
Q
I
has a
write
little tail on it.
square. This is how I write square.
You have with a look. What is going on right there? What is that? Is that a paper
It's an
clip?
A. What? That's the Do you not like my handwriting?
Oh my gosh, what happened here?
What happened? It's my beautiful handwriting.
Oh gosh, I haven't written in cursive in forever. Okay, your cursive is going to be way better than mine. Let me. Oh my gosh, this is going to be so bad.
You can only write cursive or illegible. There's no in between. That's not bad.
Better than I expected it to be honest.
Wait, you do your question marks? Wait, you do it like that?
Wait, how do you do it?
I do a little S thing.
Oh, you do like a whole. Whoa, that's really curly. I do like a. Okay, I do like a maybe sometimes like a little bit, or sometimes it just goes straight down.
I never
You've
saw.
got
I
like a
never saw.
whole S.
I can't do that. Never saw these except in like books or something. I always just
Oh
write a
yeah,
little
that's
S.
that's where I got it. I'm typesetting a book basically.
I mean, your writing is good enough.
My cursive maybe not.
Yeah, but like that's not important. No one writes a book with cursive anymore.
Okay, here I've got something danger for you now.
Oh, okay, danger.
You may have seen this before.
Mm-hmm. Ah, it's the meme, isn't it? It's the internet thing. Oh god. That's 6 divided by 2 times 3. That is 6. So it's 6 divided by 6, which is 1. Ah!
That would have been correct at the start of the 1900s, which is why all this
What?
controversy comes in. Yeah, this is how they used to do like the order of operations
What?
before
They
like
changed
1970.
math?
Math got changed at one point.
Oh my god. Yeah.
There's like actually historical references in textbooks showing the changeover from one interpretation of let me go over to yellow of this portion right here with
Mhm.
regards to this guy. So this guy kind of like messes with this a little bit. But the controversy comes right there where you turned it into 6, but actually with our modern orders of operations, it basically just counts working on the stuff inside the parentheses.
Oh, you mentioned that.
So when we have
Mhm.
like this, I mean, this symbol is very dangerous. It's why we don't really use it in math publications these days at all. When you have this right here, the parentheses fall away and turn into a multiplication symbol.
Yeah.
2 by 3, and then order of operations here, because these two symbols are going to be equal in precedence, we then work from left to right.
That makes sense. It got nerfed.
And so 6 by 2 is going to be 3 by 3 is 9.
I see.
And that's where the controversy of this internet meme comes around. There's another version of it too that uses slightly different numbers, but essentially it's doing the same kind of confusion where they have this division symbol and then they're trying to confuse. A lot of people also say that they want to do like some kind of distribution here.
Yeah.
Which, yeah.
I think that's
It's
just makes it more complicated.
Yeah.
Like when you don't have numbers, so when you have like X in there, then yes. But otherwise, I'm not doing that.
I mean, speaking of putting X in there.
Oh god. Okay.
We're gonna go into algebra a little bit. So we took a look at orders of operations, and we've got a little bit of a refresher there of which symbols come first and having equal precedence and all of that. And we practiced some basic addition and subtraction. Very good study there. And now we're going to go into a little bit of algebra. Let's take a look at my notes. Yeah, so basically, Oh, that got a little bit messy. Algebraic equations. So we've got the concept of a variable, which, it's basically just a little letter which can represent some sort of value. Most often you'll see it as the letter X or the letter Y, but basically any kind of letter or symbol can be used depending on the context or depending on the problem. You might have capital letters, you might have symbols, could have all sorts of things. The important thing to know about variables is that, they simply represent a value. Sometimes that value is given to you. Sometimes you have to solve the equation to figure out what that value is. I have also a couple of examples here that we can work in. 5 plus 3e, where e is equal to 5. So this, I'm writing really uphill. We're just going to do some very basic variable substitution, and then go ahead and solve the equations. So this right here will have basically an equal symbol.
Okay. And now I paint in with my pink pen and say that 3 times 5 is 15 plus 5 is 20.
There we go. Easy peasy.
Yay!
Then we'll go into the next one. We've got 21
Spoon, it's
minus
not
2x.
not a math game, Spoon. There is no game, it's just math.
It's kind of a game if you're collecting the gold stars.
True. Did I get a second one?
I think you deserve a couple more than just a second one from what we put you through already. I'll have to keep a running total somewhere.
We can just look at it at the end.
21 minus 2x.
I have a
Where x is
question.
7. Yeah.
Do you always write the where in America?
Not always. Sometimes it will just be there as like we'll just put like a little comma and then say x equals 7, like in this shorthand notation.
Yeah,
sort of
I
thing.
never saw them anywhere where it's like where x equals 7, unless it's like in a wall of text.
Wall of text is coming soon. Don't worry.
Oh, okay.
Here, I'll get rid of these though.
Okay.
Thank you, Fruit, for the follow. Welcome in.
Math is fun, Spoon. Exactly. Again. Once we get to the 2. Are you scared of X on both sides?
We're gonna have some x on both sides.
Let's
Let's see, where do I have this in the lesson plan? We've got some of those. They're not too far away.
Let's go. Wait, that's just right. That's 14. Okay, so 2 times 7 is 14. Now we do the hard part, the subtraction.
I will forever be amazed that multiplication and division is easier for you than addition and subtraction.
The thing is, the times table, I basically know it from the top of my head. You can just be like, what's 7 times 8? And I could tell you, oh, it's 56. And like, you could wake me up at 3 a.m. and I could do it, but addition and subtraction, no.
When I was younger, I had a big problem with the 8 times table for some reason. It just, 8s were very strange to me. 7s, no problem. 8s, never heard of them.
8s are kind of hard, but I think the one I struggle the most is 7 times 8. Like, I think I only learned that in high school. That's the worst one.
Yeah. I think that was the worst one for me too.
No, it's
for some reason it just doesn't make sense.
It doesn't make sense. It's so terrible. It's just a random number in there. It doesn't make any sense. It has no system. Okay. I forgot to do math along the way. Wait, is it just 7?
Yeah, it's just 7.
Yeah, it's just 7.
It's just 7.
I just did the ones first, and then I was about to do the tens, and I was like, wait, 20 minus 20 is.
What's funny about doing multiplication in your head these days, right? I have an issue waking up on time with alarm clocks and all of that. So for a while, I used this alarm clock on my phone that makes you do math before it will turn off. And I ended up getting so to the point with this app where I had stuff like 2, 3, 5, 4, 7 times 9, 8, 0, 0, 4. And I would solve that in my half zombie sleep stage, and then go back to sleep.
And then go back to sleep.
And then go back to sleep. And then I would wake up later, and the app, what it did was, when you would correctly solve your math problem, and it would turn off the alarm, it would like take a screenshot and make a little log of it, and saying, "Yeah, you solved the problem at this time, and your alarm turned off because of it." And I would look at that like 3 hours later and think, "Who am I? How did I do that?"
I don't even know how I would solve. That's a very high number right there.
That's an incredibly big number. I mean, math cannot stop me when I'm tired.
Like, I could probably try to do it. I just don't see a reason on why I would put myself to that suffering right now.
We're just gonna hang on. Where's my selection? We're just gonna delete that before I get tempted to solve it. Here, I'll give you the next one. We've got 88. 88y minus 22y. Y is equal to 4.
Y is equal to 4. Okay. Oh, so 88 times 4. 8, 16, 32. Wait, no. It was this one. And then it's 320. And then we have... Gotta move my screen so chat can see what I'm doing. Then we have 352. And then we have 22 times 4. Which is 8, 80, 88. And oh my god, this is so strange. Okay. I can do this. I can do this. This is easy.
Subtraction time.
This is easy. Okay. Give me a minute. So. I'm looking at the numbers. My brain is stopping.
What are the numbers telling you?
The numbers are telling me 6. 6. There's a 6 at the end, probably.
There's a 6 somewhere.
Yeah. Oh, somewhere. Okay.
There's a 6 somewhere.
Is it at the end?
No.
Oh, that's unfortunate. Wait. Then my brain is not telling me the right thing. 352 minus 88.
Oh, you put your minus symbol over there?
Where did you put it?
I put it over here.
What?
Huh?
These things just keep piling up. What?
What the heck?
What?
350. How would you wait? How do you read your version out with voice?
What do you mean?
Like, if you were to tell this equation to me with your voice, how would you say it?
352 minus 88.
But you've written it 352 88 minus.
I can see it's a minus. It says it right here. What?
Yeah, but it comes after your 88.
That doesn't matter.
See, when I do it, right, I read it like top to bottom, left to right, like a book. So 352 minus 88.
That makes sense, but also I don't agree.
And when you do it, you're like 352. Okay, this line is now backwards. Minus 88.
To be fair, as long as there's a minus, I think people can tell it's subtracting.
I mean, that's true. That's
Like-
true. It just
like you
surprises me.
You can, like, yeah. Maybe it's just a thing we do in Germany, because we also say, like, 250.
I didn't expect it.
Yeah, we don't say, like,
okay,
52,
yeah.
we say
Wait,
250, and so we do that in a few things. So
maybe that's why.
I have no idea.
Maybe it has something to do with that.
Yeah, we say, like, 100, 250. Don't ask why. Language.
I think it wouldn't be a smart idea to ask why.
I don't think there's a reason other than language is being quirky. Okay. Maybe it's just it's easier to do math because you do the ones first and then the tens, and then you can just calculate it in your head and say like 250, and it's the correct number.
Hey, if it works, right? I think this is one of those things where it's like, yeah, different people will think of it in different ways.
Maybe. Okay, we have 12 minus 8. 8, 9, 10, 11. That's a 4. Why did I think 6?
I'm not sure.
I have no idea. Alright, then we have 15 minus 9. That's the 6.
There's your 6. You found it.
I found my 6 at 264, and I don't even remember what I was calculating.
Yeah, we have to scroll back and look at what were you originally
What was I
doing.
doing? Ah, yes, here it is.
88y minus 22y when y is 4. 264 is the correct answer, but
Oh,
but there was something simpler that you could have done at the original part of the equation.
mm-hmm.
Let me move. We're going to continue to just go southward. So when we have 88y minus 22y, because these are both using y, it's the same kind of unit, and then we can combine them. And so we can already start off by just doing 88 minus 22 and end up with 66y.
That makes
says-
yeah, that makes sense.
And then you would substitute y for 4 and then do your math there, and you would end up at the same number. But basically it's just, you can combine like terms to simplify equations, and you might have reduced steps in longer equations.
In this case, it still would have been 2 steps. It's okay.
Yeah, in this case, you're totally correct there. In this case, it still would have been 2 steps.
You're doing math? Yeah, I'm mathing. Elvie is
We're
teaching
mathing
me
today.
math. I want to see how we're spreading up across the camp. This is beautiful.
This is amazing, actually. Where are we even going?
No we just keep going into the corner.
Wait,
just keep going.
we've still got like the category headlines all the way up at the top left, and somehow we just travel down to the, not even like down in a straight line, but down into the side.
Then next, find out the equation for this graph.
This is amazing.
Oh. Okay.
So what have I got next then? Okay, so in the same direction as see this is a beautiful segue right here. Now we're going to start working with some combining like terms to be able to simplify some equations. So these equations are going to have some missing information. They're going to have some variables that we don't know the value of, and so the best that we can do is simplify the equation and turn it into a smaller version of itself. So we've got here minus 4p plus a negative 2 plus 2p plus 3. And I won't put an equal sign because we can't actually solve it all the way to the end, but we can simplify it by combining like terms.
And I'm assuming that's what I'm supposed to be doing.
Yes, please.
Okay. Okay, we've got the negative p right here, and then the plus 2p. So we have negative 2p, and then we have negative 2 plus 3. That's plus 1.
There you go. That's the answer. So we'll jump directly into the next one because that one was too easy. We've got minus 4y minus 4 plus negative 3.
It's negative 4y. Negative 4 minus 3. 5, 6, 7.
It's always the 7.
It's always the 7.
I've somehow collected a lot of 7s here without realizing they were your arch nemesis.
Everywhere where I'm pausing, there's always a 7. People say it's a lucky number, but it hates me. Okay.
You know what I can do? I can give you gold stars this way.
Yay!
We've got... Oh, hey, we're coming into our first decimals now. I hope you can work with this. I'm gonna write them American style.
I'm gonna write them European style, just out of spite.
Perfect. I'm totally okay with this.
I reject the American style, but yeah.
You know, this wasn't even... Oh, I hate that 8. I'm redoing that 8. This whole thing with decimals, I totally did not even have this in mind as I was preparing these equations.
You're just making them up now.
The decimals?
Yeah.
No.
Oh.
No, these have been in use for thousands of years.
God damn it. Oh my god. Okay, well, we can cut these, I think. That got me so off guard.
Oh, gosh.
Oh, man. Yay! Math brain.
The brain is braining today.
Doobie.
Okay, let me move this a little bit lower. So we've got now the next one. So we've got 6. 1 over 2w minus 3 over 4.
Okay, wait. So Wait, how? We just do this thing, right?
Yeah.
So that's
Yeah, we have to do that thing in this case, yep.
6 times half a W. And then we have 6 times plus 6 times negative 3 quarters. Doing this 3 with 5 dots works. And then I don't know what to do on this half, to be honest, so I'm just gonna start with the back half. And oh god. Wait, this is like 6 ones. When you do the top one, 6 times 3. 6, 12, 18. Oh god, I need to just think of the minus. 6 times. Where's the minus? It's in the bottom, right? Ah!
Should I interrupt and help, or do you think you're good?
Wait. I think I'm trying to remember math class. I can just do something else. That is the same as 6 times negative 0.75. Can I do that math easier? That is the question.
Oh boy, can you do that math easier?
I'm determined to avoid 3/4. Okay, wait, but that's we can also just draw this, you know? Like 3/4 is easy to draw. We have
Yeah, if you want to draw it, go for
we
it.
have 3/4, and then we have 1.5. I'm drawing it in my head. Right? Yeah, 2 times 3/4 is 1.5. So and then we take another 2 times, that's 3, and then we have 4.5. 4.5. Is it with a minus or not? Okay. This is the limits of my math brain.
I mean, 4.5 is already a really good step in the equation.
That's good. I just maybe there's a minus, maybe there's not. I don't think. Wait,
Maybe.
no, there's minus and minus is plus, and there's an even number of minus, so there's no minus. Okay. And then, I can multiply these, right? 6 times a half. That is 3W.
Mm-hmm.
So we have 3W plus 4.5.
You go very close.
Ah,
It's a little bit incorrect. It's minus, yeah.
Minus. Gotcha.
It's minus because when you did your distribution up here, you changed it to a plus symbol and took the minus symbol in here, but actually that's not necessary to do.
Ah, okay.
And so what you can have is you can have 6 over 1 times 1 over 2, and then you can also have, I need to scroll to look at the equation over there. There we are. And then you can have 6 over 1 times 3 over 4. And you end up with, yeah, basically what you did there at the end. You end up with 18 over 4, which can be simplified to 9 over 2. And over here, 6 by 1/2. Yeah, you can also do that in mental math like you did.
3.
And so that ends up being 3. So you end up with 3W minus, and yeah, there's a couple of different accepted answers here. You can either say 4.5, or you can say 9 over 2. Pardon me for putting a decimal dot in the middle of a number.
You're forgiven.
And then here, hang on, I have to go back and I have to give you your gold star.
Yay.
There we go.
Wait, I have a question though.
Yeah.
In the case that you do this thing,
Mhm.
where is the minus?
So the minus is actually still chilling right here.
Yeah, no, but like if you have like 6 ones times -3/4, if you would still have that in theory, you do like 6 times -3 and 1 times -4. Wait.
Okay, I see. I think I see what you're getting at with the. Yeah, if I remember this correctly, it ends up just sticking to the top one, because the bottom one, the denominator, is basically just saying what kind of shape is it, so to say.
That makes sense.
I would want to double check notes on this before I speak something totally incorrectly, but I believe what it would end up being is
like it seems
essentially
logical,
looking like
yeah.
this.
Yeah, because that was where I got like confused. The first one, because I was like, which number does the minus belong to?
I did intentionally leave out a lot of the fraction work that we could have done, multiplication and division of fractions, because those things can get pretty gnarly. There were some examples that I saw when I was preparing that was something like 1 over 2 multiplied by 7 over 15, all of this over 3 over 4x times 2y, crazy stuff like this as one equation.
That's what I did in math class.
Yeah, these are terrible. There's so many steps to it.
This is still doable, like, but as soon as you have like here x plus 5 or something, no.
Yeah. No, I mean even I am not a fan of this kind of math. It's too many steps, it's too much division, it's too much. Yeah. I decided to leave a lot of those out.
Yeah, I understand. I think I would have very struggled.
Yeah, so this right here, this section that we just did with these couple of equations here, this was all basic variable substitution. So yeah, we understand that a variable can hold some kind of value. Sometimes this value is provided, sometimes this value is not provided. In the case where it is provided, if we have all the information we need to solve the equation, then we can go ahead and solve it to a final answer. But in the cases that we don't have all of the information, the best that we can do is simplify it down to another smaller equation.
Okay.
The next thing that we can take a look at is inequalities.
Inequalities.
I wrote that very messy. That's fine. So inequalities, we've basically got a couple of these funny looking symbols. We've got less than, we've got greater than, got less than or equal to, and we've got greater than or equal to.
Inequality. That makes a lot of sense.
Because they're unequal.
Yeah, I never heard the word inequalities before, so I was like, huh? But yeah, no, that makes complete sense.
How do you call them?
I don't know. I don't know if there's like... I never learned the word above it. Google it, wait. Can I find it?
Rylan says, is that Helvey, the grand world-renowned, well-loved crack teacher? Stick around for a little bit, Rylan. You'll find out I'm not all that cracked up to be here. We're discovering math together.
I'm not sure if there is a word for it. Like, at least I can't find it. Oh wait, no, they are being called inequalities in German too. My teacher never used that
What is it in
word.
German? Like Inequalitäten?
Ungleichheiten.
Ungleichheiten. Of course, I Americanized the German there.
Fine.
That makes total sense, though.
Go.
Math schmaths.
Smash.
So, yeah.
Yeah.
Let me grab this guy here. Let me grab this color here. And so the way I learned...
Rylan, thank you for the follow!
Nice, we got follows going.
Yeah!
The way how I learned to remember less than and greater than is that this is like a funny creature. Exactly. And he's always chomping the bigger amount of fish. I'm so glad that we learned the same thing here.
I learned that he's a crocodile, though.
Yeah, I learned crocodile too, but there was no way I was drawing a crocodile. I don't know. Do you know how to draw a crocodile?
I think kind of like this.
Okay, yeah, we've got a little snout. We've got a little flappy.
Is that a crocodile?
It's way better than whatever it was I drew. Here, we can use some of my... Oh, that's not a rotate. I thought I could rotate my line. They don't have a rotate tool?
They don't have a rotate tool?
Wants me to... No, yeah. Can't rotate. Oh, wait. No, it's here. It's hidden. It's dark black. That's why.
I see. Ah. Dark mode problems.
I'm normally using light mode for everything.
That became an art lesson very quickly. I mean, we've been doing math for 1 hour 20 minutes. It's not that quickly.
Yeah. Well, I need the teeth back here. There we are.
Nice. It's a beautiful crocodile.
I mean, that's the other thing too, right? I'm terrible about remembering to take breaks during studying. If you need a break at any point, just let me know.
I'm good.
Okay, cool. Because like, yeah, I can just tunnel vision and go for hours.
Same.
I mean, I
ADHD
like I
hyper-focus into the...
exactly. I
5
mentioned
hours
earlier.
math, no break, easy.
Yeah. I think I woke up this morning at 10 a.m. and I was just finishing preparing this lesson ever since then, and then we hopped directly into the stream. So,
oh well, that's a lot of it.
It's been a lot of math today.
No, I feel that definitely. Yeah, just
I have to second guess myself at some point for some of this stuff there.
Wait, are we trying to escape from math? No, it's not. It's part of the math lesson. It's the crocodile.
So it's part of these inequalities. One thing that we can... Let me switch over here. One way that we can depict an answer for an inequality when we find a solution to some of the equations we're going to take a look at, there are two different ways that we can represent this. If we have, for example, and here I'm going to look at my answer sheet to make sure I don't accidentally pick one of the actual answers that's upcoming. If we have, for example, if we want to say that for one of the inequalities the answer is b is less than 4, then we can just simply write that, b is less than 4, and that would be an okay answer for the inequality. Alternatively, here we've got these little... Oh boy, straight lines. Can I draw straight lines? Yeah, I can kind of draw straight lines.
Close enough.
We can use a number line. Just split this up a little bit. And so if we have, let's put 0 here, 1, 2, 3, 4, 5, 6, -1, -2. So another way to represent an inequality is on a number line. And on a number line, yeah, so if b is less than 4, then we would say, we would circle the point where 4 is and draw an arrow to the left because it's less than. and draw a little arrowhead over here as well. The reason why we put a circle at the 4 is because we're saying we don't include the 4. It has to be less than 4. So the answer, whatever B theoretically could be, it could be... That's not a 3. Wow, what happened to my hand there? I don't know what I just did. Thank you. Thank you for helping fix my 3. It could be 3, 9, 9, 9, 9, 9, 5, who knows what. But it will not actually touch the 4, and so we put a little unfilled circle there at the 4 point. However, if we had just to show the other case, if we had here, let me put this actually in a different color. If we had C is greater than or equal to 4, then in this case we would have a filled in dot on the 4 position with an arrow going to the greater than direction. And that would say that we're including 4 as the possible answers of what C could theoretically be, because it's filled in, the little circle there. So we have 2 ways to display an inequality. We can either do so just in its plain number format, like B is less than 4, or we can do so on a number line, where we're actually using this kind of arrow notation to show how there are multiple values that could possibly fit into our variable to make the equation true. So with that all said, and with us having this little table here of less than, greater than, or equal symbols, I have a couple of equations for us to take a look at. So we're going to start off with 4x minus 1 is less than 11. And yeah, just like with our previous set of equations, if we don't have the full set of values here, if we don't have the data of what x is, then yeah, we basically reduce the equation as much as possible and make it smaller.
Okay.
And yeah.
Wait, it's not equal. Did I math?
Quick math.
Wait. Yeah, okay.
That's it. That's correct.
I just want to jump in and say I never saw the number line thing before.
You never saw the number line thing
I never
before.
saw that before.
All right, I need you to map x is less than 3 on a number line.
Like I know what I never did like the greater stuff on a number line. It's the with the arrow.
Right.
I'm like,
that's why I need you to do x less than 3 on a number line so I can see that you got the lesson.
Okay.
I'm concerned now.
What do you mean you're concerned?
I didn't see a number line ever.
I saw drawing graph thingies.
I'm just teasing.
That's all I ever did with that.
Oh, those kind of graphs, slope graphs.
Yeah. I never saw this.
I was gonna give you slope graphs today, actually.
Ooh.
But I thought maybe that would be a little bit complex because then we'd have to constantly draw graphs every time. And I didn't feel like digging out a graph paper or something like that. I could have done. And then I was also planning out things like this angle, XYZ degrees, XYZ degrees.
Yes.
We nearly had a whole bunch of this today.
Next time.
Next time.
Now we have to do it next one. No, it's fine. This is the fun math. The funny.
I do like this kind.
Funny lines, yeah. The funny lines.
It's almost like a puzzle.
Yeah.
The Layton games have a lot of this too, or at least sometimes it's like a trick where you think you have to go into this, but actually there's a super simple answer that you just have to notice.
Yeah, the Layton does that a lot, trying to make you do math, and then in the middle you realize, wait, this is stupid. There is no answer here.
I actually remember one. I looked it up right before stream.
You're so smart. You should be an engineer. No, I'm gonna waste my talents in graphic design. Thank you very
You
much.
basically have to be an engineer if you're an alien with a UFO, aren't you?
I bought it on Space
On
Bay.
eBay?
Yeah,
Space Bay.
Space Bay.
What happen? What do you do if it breaks down?
I call an engineer over. It's pretty expensive because space is really big, so the travel cost is like insane. So just
Oh
pray
yeah,
it
I bet.
doesn't break down. I remember doing this in Layton. Wait,
Yeah, you saw this one?
I did this on stream, I think.
Yeah, okay, I have to go find the VOD later then. What was it? And then it had like a line here, and then it was
It
like,
had the line here to trick you.
yeah, one of those. Yeah, exactly. Yeah, I gave the answer
Yeah,
already.
yeah.
This was 5. This was 5.
Yeah.
It was like, okay. BD, what is AC?
That was
Yeah,
like, what
yeah.
is BD or something? And then you're like, oh, but BD is AC, and that's the line thing. That was
Yeah. Yeah, because this is just the radius right here, which is the same as that. And that is the same as that.
Yeah,
Silly
man.
Layton.
Geometry
Silly
was
Layton.
fun. Geometry was fun.
I'm looking forward to the next Layton stream.
I really gotta do that. I'm probably gonna try and do it next week, though it won't be on Tuesday. I have a collab. But
Ooh.
maybe Friday or something. I'll fit it in.
Okay.
I definitely have to continue playing if you want to get through all the Layton games.
Oh, you're gonna do all of them?
I at least want to do the first 3 that are on the on the phone on the App Store.
Okay, that makes sense.
To train for my when the new Layton gets released, right? They announced that one is coming for the Switch.
It's a training arc.
Yeah, I said I was gonna do a no hints coin run. So I'm training. And I will regret saying I'm not gonna use any hint coin. Okay.
Did you play the one that's already out on Switch?
I played it on the DS, I think. And that's the Catriel Layton spinoff, right? Or the one with the girl daughter.
Hang on, I'm looking on my bookshelf to see the title.
I have it. Yeah, but I think
Layton's Mystery Journey, Catriella.
Yeah, Catriel.
Oh, actually, yeah, I forgot all of my games are in German. I was about to read it in English, and I didn't put my mouth in German mode. Catriella und die Verschwörung der Millionär.
Yes.
Exactly.
I'm gonna just do this properly in my head. Wowie. And divided by 10, we have 3 and 4. Wow.
This is also a thing I never saw before.
Nah?
Yeah.
Eh?
I saw Megu write about it in your chat, I think.
Yeah.
Also totally a concept I've never seen.
Do you write the full thing every time?
I'm not sure that we would have this kind of like notes on the side at all. Like we would probably sooner go into long division and say something like 10 40.
What?
And then go into long division like this.
Why would you? I mean, I think it's just a note for like it's the line thingy. It's kind of like, oh yeah, what am I doing? Because when you have really long equations, and then
Right,
like,
that makes sense.
Yeah, I'm dividing by 3, so people who stare at you on the teacher knows. Oh yeah, you divided by 4 in accident. You're a dumb.
See,
but they know what you did or tried to do.
Okay, the difference here when we go step by step in our problems for the teacher to actually see, we just completely leave out this section, and we just have these right here.
Oh god, that sounds terrible.
And that's it. But I mean, yeah, there is the risk there that you have to make sure that the individual steps there actually make sense to the teacher, because
Yeah.
if one of them doesn't make sense to the teacher, they just mark it wrong.
Yeah, no, what I used to do is when it was like easy, I would just write, oh, wait. Every time I go to eraser, it's almost my pen. I go like, oh, -5 divided by 3 minus x plus 3, and then I would do it on one line, and the teacher would like know what I did. So I didn't have to do 10 steps.
That's wild. I mean, because the thing is, right, this then almost feels like absolute value lines to me. And so when I see that, my default, like the thing that immediately pops in my mind is, oh yeah, absolute value 5.
Ah, oh, that makes, yeah.
Um,
I see. Yeah, no, it's a little no. I think it's also easy when you like look at your notes and you're like, what did I do there? Like you wrote it there, you know what you did.
Right, that makes sense.
It-
I mean,
it was
I've said this in the previous study streams as well, but taking notes is like one of the absolute best things you can ever do for studying.
Yeah.
But yeah, you get a gold star for that one.
Yay!
I think I didn't go too crazy with these inequalities here, so this should be okay.
Yeah, you can go crazy.
I mean, to go crazy. Sorry?
Mego ask if they can give me a difficult question. Sure.
I mean, if they got one,
Yeah, if you have one.
you can write it in.
I can't do it without writing the thing.
Yeah, go for it. It's okay. I
just
mean, now that I know what it is,
yeah, it's a little funny thingy there. Okay,
it's a
15
little
minus
funny
8.
thing to do.
That's 7? 7. And divided by -3. And we have x is great. What is 7 3? Math. Oh, it's
This one is not quite correct.
huh?
There's a slightly easier way of going about it too.
Okay, wait. Can you tell me which line I made there?
If you want to go for the easy route, the first line.
Oh, okay. Eh?
I hope you don't mind that I use red. It's simply the color that I already have pre-selected.
Teacher color. It's alright.
Don't start with that guy. Start with that guy.
Why would I?
This is how I did it, at least.
I
It was a little easier
I don't
for
know.
me.
I kind of. I guess it makes. So you're saying to divide by -3 first?
Mm-hmm.
I learned that that's taboo, but
Really?
yeah,
How come?
because it's easier when you just have when you get when you his language. Like when you group them first, like the 8 and the 15, and you put them on one side and then the x on the other side, and then you're like, oh, now I just need to divide by 3 and I got the answer.
That's true, but in this case, you have a little bit the easy thing that
I'm gonna try doing it.
the 3 and the 15 can interact with each other with whole numbers.
That's very true. So we do divided by -3 first, and we have x plus 8. I also divide the 8. That's also why I don't do it. And then we have -5 minus 8.
Okay, I will walk through this one, how I did it, because it is a little bit of a trick question.
Okay.
So we've got -3x plus 8 less than 15.
Mm-hmm.
Let me double check my notes. That way I can explain without lying about anything.
fine. You can lie to me. I wouldn't know.
I don't want to give wrong information. That would be bad. My reputation's on the line.
I would just believe you.
So we have here minus 3x plus 8 less than 15. And so we are going to divide this by, or actually this whole thing, minus 3. And then this side also by minus 3. These guys cancel out. And one important thing to remember, this I also had to relook up, is when you divide an inequality by a negative number, the symbol actually flips.
I felt like that was tricking this question. But I didn't have the confidence to do it.
So now we've got x plus 8.
Moon, thank you for the raid. Hi. Welcome, welcome. And thank you for the resub. How's the stream? Okay, I see. That makes sense.
Although I'm writing something wrong here.
Do you?
Yeah, I totally wrote something wrong here.
Oh.
This equation might be bust in terms of explanation. Here, let me show you the answer, and then we can work backwards towards it together.
Okay.
So the inequality at the end is x greater than minus 7 over 3. So we've got the flippy-do when we divide both sides by the minus 3. And then for whatever reason, my brain cells are not rubbing together and making a spark in terms of how we transform this guy into this guy with the subtraction of the 8 there.
And then we have negative 15 thirds minus 8, 1. And then 8 times 3 is 8, 16, 24. No, wait. Yeah, 24, right? Is this mathing?
I mean, if we continue with this, then we would have...
Then we have a different answer.
Then we have a different answer. Because that will make 39 over 3, which can then be reduced. 39 over 3 is 13. That would end up with minus 13, but that's not the answer. I knew I was going to make a mistake somewhere in my lessons.
But I also have minus 13.
Yeah, minus 13 is incorrect.
Oh, eh?
It's definitely this guy right here.
Huh?
And I have confidence in saying that because the equation didn't come from me.
Okay.
It came from an online math platform that I actually did the equation correctly and read their explanation for it and copied the answer. But now I'm like, wait a second, how do we do these two numbers together?
Wait, now I'm confused.
Should I go look up the answer again?
I don't see a way. Like, we obviously have to subtract 8 next, and we have negative 15 thirds.
Hang on, entertain chat for a second. I'll go
Okay.
find the answer. Oh no.
Oh my god. Okay, Moon was Naraka fun. Thank you for the raid. Welcome. Oh my god. Okay, I'm going to do Mega's question that I missed. If a truck is driving 150 kilometers per hour and a child appears ahead on the truck going 1 kilometer per hour, will there be anything left of the child? What the fuck? I don't even know what. Oh, that just means that is I don't know the correct term. Wait, that is just this. It means it's less than. It's not equal, it's an inequality. Yes. So we're trying to get the answer that x is bigger than -7/3 for some reason. And it doesn't make sense. Yeah, what does it do in equation? It's basically it's not it's the same thing an equal sign does, I guess. Just it means something else. Does that make sense? Ah, yeah. It's not x is not equal. It's not x is not equal to -7/3. It is greater than. I don't understand. Wait, let me grab a calculator. Wait, isn't there these online websites that do these step by step for you?
Wait, that's like a full calculator?
There's like websites where you just put your entire equation in and they calculate the answer and give it to you step by step. Alright, we have -3 x plus 8. I hope they can work with greater than. I tried that. It just gave me a check mark. I was like, yeah, that is correct. Oh, that did not help.
My stream is going to have the sound effects of this online quiz program as I retrace my steps into finding the equation that I might have borrowed inspiration from.
Okay, -3x. I'm trying a different website. I need to know. I'm helping. Plus 8. There's again no. Why is there no greater than button? Yeah, they're not built to do equations like
What the
that.
heck are these
Where's the one
numbers
that
on
I had?
screen?
Hi, Dango. I don't know what the heck these numbers are either. Show me the task. This is the task. This thing right here. And like I got -7/3 or something. Right? I did like -8. And we have -3x is greater than 7. And then divided by -3. And I guess this turns around? Or something? I don't know. But like the correct number is supposed to be... Wait! Which was the... Wait, is the -7/3 the correct number? Elvie? Did I do it correctly? No. Did I? Oh, I accidentally muted myself.
I was wondering where you went.
I'm sorry. Wait, but the answer is
What?
-7/3, right?
Yeah.
That was what I got the first time.
Wait, you have -7/3? Where?
Yeah, at the
Wait,
very
what?
top, at the very top, above that, above
Hang
that.
on.
When I did the -8 first. Here it is.
Ah, right. Yeah, no, I wanted to explain then that you needed to flip the flip
Yeah.
the
So
symbol.
like, yeah, when we divide by
Yeah,
-3,
yeah,
it
yeah,
just.
yeah.
Oh, I did get the right answer.
Oh my gosh. Hang on, let me. Where's my pen?
The second math is just broken. I don't know what's going on here, but
I don't know what I did there. I had gotten to the correct answer at one point in my life. Here, I'll give you a retroactive gold star.
your symbols are
Oh.
different to what I learned. What do you mean, Dango? What do you...
This one right here is from my personal collection.
Okay.
I have to lose a star for it.
No, okay. That is amazing. I don't know what went wrong here, but what
Something happened.
something happened. We don't talk
Something
about it. We
happened.
just don't look
We
at
don't
it.
talk about it.
Just keep going. Just don't look at it.
We've got more equations to look at.
Okay.
Was that the okay? Yeah, that was the one that we just. How
Oh,
did you do with the
Dango.
truck problem?
The truck problem. I didn't solve it. I don't know how much is left of the child.
Oh no, the child's gone.
Child's gone. I don't know, man.
Yeah,
No, okay,
search
Dango,
party.
wait. Okay, I'm gonna. This means greater than. This means lesser than. Not
We've
equal.
got the whole table.
It's not equal. Yeah, I got a little table.
Okay, we got the table up here. Where's the
not
alligator?
equal. It's an inequality. Yeah. Okay, got a little excited. there.
Nice. That's good. That's the kind of energy we're looking for.
Yeah, math.
Math, let's go.
And these lines are apparently just a German thing. Don't worry about. This is basically me announcing what I will do in the next line. So if I have this thing and I'm like, oh, I'm gonna subtract the 8 on both sides, then I write the line and I do -8. Helby also doesn't know it. It's a B thing. It's a German thing. The crocodiles, yes. Exactly. Okay. Okay.
Do you know Karu? I don't know if you know Karu.
I don't think
He's in one of the friend circles, and he's always represented by an alligator and everything.
Oh.
Hime in my chat just said, "Hey, it's Karu."
Okay. Wait.
I had to scroll down far.
Yeah, dude, that's
We're
like
down
so
by
much
the
space.
Yeah.
Cat face.
I don't know what happened. We just block off that area
Just
of the
don't-
board.
Just don't look at it.
It's locked into the archives.
That was way a little much of struggling. Okay. Is that a 9 or is that a Q?
It's definitely not a Q. Hang on.
That did not fix it.
Hang on. Hang on. Hang on. Okay, we start over. 9. Is that better? No! Now it's an umbrella.
An umbrella.
Ella.
Okay, it's a 9. That's good.
Oh, you can have the little umbrella. That's okay.
Okay. Well. That's not an umbrella anymore, that is. I don't know what. Weird looking sunglasses. A monocle.
It's certainly something.
Okay. So we do -9, since that's all apparently the correct way. And then we have -4D is greater than -12.
I'm secretly praying that you just get all of the rest of these correct.
It's fine. I've learned from my. I just do my way. And we'll be fine. We'll be fine. And then we have D, and then we flip it around. flip it around because we divide by a negative number for some reason. And then we have 3. Right?
Yahime, no thoughts, heads empty at looking at these numbers. I think we've reached that point as well.
Oh.
We're just here for the ride now. We have no idea what's going on.
It's funny how one of the best physicians came to be because he experienced an apple fall and thought, wow, this shit's nice. I'm pretty 99% sure that is just a story they tell to sell that stuff. I'm 99% sure he did not discover that stuff because an apple fell on his head. It's like an urban legend. Oh, that's big numbers. 72.
Yeah. 72.
Oh yeah, we do a +8.
You're gonna have to break out the 8 times table.
8. Wait, no, we just do +8 and that's... I was gonna say that's 80, but it's not. Books, thank you for follow! That is... I can do math. Wait. That's... 4... 64? Yes. Pretty sure it is. I'm confident. Then we do divide it by 8. Then we have x. But it stays because it's not a negative number, right? And... That 8 times 8 is 64. So... Yay! I was totally confident in that one. Yeah.
Waiting with bated breath to see if the answer's correct or not.
There was no question mark there.
As I fumble for the ink color.
I was like, oh, is it gonna be a red pen or a yellow pen?
Oh boy.
Oh boy. Not a clue how any
like
of
my
this
handwriting
works. It's just math. What do you mean?
None of this works. Math is a little bit like faith. You just have to believe.
Yeah, you just, I don't know. I think math, it just works itself out. You know, you just push the little numbers around and then suddenly you got x is 2 and everything is fine.
Exactly.
Yeah, just trust the process. I think this is a very trust the process thing. Okay, that is... Numbers are starting to lose their meaning. Oh my god. Okay. 32 divided by 4. That's 8 minus -8 again. Yay! Okay.
Good job.
Yay!
We've got one more.
One more. Okay.
And God forbid this one has issues.
Oh god. Okay. It's fine. I believe in us.
I'm glad one of us does.
I believe. Okay, what? I don't see issues. What are the issues? We do -35. We just do the same stuff, right? And then we have that, and that is greater than -33. Wait, how do you divide that by 4? Is that the issue?
I mean, actually, I looked at it. We're good so far.
We're good so far.
So far, everything's good.
Still good.
It's still good.
Oh, okay.
It's still good. Hang on, I'm changing to yellow ink.
Okay, okay.
Okay.
How do you do third?
Perfect. That's literally the answer.
I was like,
Once you get to a certain level of math, it's like, okay, we don't actually need to solve division anymore. We just leave it as this funny
yeah,
line number.
I was like, I don't instantly know the answer. I'm just gonna do this and hope no one calls me out. Ah,
Okay.
okay.
I'm gonna type some text now. Gotta configure the text tool. Because we've got some word problems now that we can do.
We always have to give us decimals. That sounds like a you problem.
Oh, that's too big. Maybe we'll go like that. Is this gonna copy paste correctly is the question.
Let's hope it does. Yeah, but I think I don't know, it was 50-50. Like the teachers did not my teachers did not care how you wrote the answer. Unless it was like correct, whether you wrote them the funky, lazy way or with decimals. Unless like the answer was like, hey, give it with decimals. With like 5 numbers behind the 0. Okay, you downloaded a video game to your computer. Okay. Yeah, that sounds realistic. Yeah, a 60-minute
I
free trial.
borrowed inspiration.
It takes X minutes. Oh, okay. Ah.
It's a little bit small to read. I hope it's okay.
5 Oh look,
Yeah.
you did the line one. Haha.
Yeah, I need all the space I can get.
Set the game and 7 1/3 minutes to play each level. You want to find out how many levels you can play for free. Which inequality describes the number of levels.
Yeah, I gotta paste those next. Oh, is this gonna paste? No, this is... I'm gonna have to draw these. These are more complex. Okay, so we've got 4 options here.
Oh god, we get options. So it's a guessing game and not a math game.
It's a guessing game now, yeah.
Oh, nice.
I mean, you might need to do some math on the side. We'll see. I don't know.
I can just 25% chance.
That's true.
Like that.
I mean, in another way of thinking, it's a 50% chance because it's either correct or it's not.
Yeah, exactly.
Your chances just got increased by 25%.
This is how I sound like when I'm playing Gacha. I can spend 20 more bucks. It's like a 50-50 chance. Pretty much guaranteed at this point. Those rates sound good. Yeah, what 0.2% chance, Kelby? Oh, that is a good rate.
I mean, for every time that you pull and it doesn't come up, the chance just goes higher, right?
Yeah, that's how math works, right? If you get a 1% chance after 100 pulls, you have it guaranteed, right? No way, that can't go wrong. And if it's not at 100, then definitely the next pull, right? Then the game is just a little brokey, like. Okay, what do we got here? Oh god, okay. I see where this is going. Okay, let me do some thinking while
you see where this is going?
Yeah. Yeah. Oh god. Oh god. They all have the numbers.
They all have the numbers. There's no easy outs here.
God, oh no. Well, these answers are longer than my future.
Oh no. Oh no.
Do you need help? Do you need help, Owen? Are you okay?
Okay, we're good.
Okay, okay, how many levels can I play for free? So the 5 and what is this line?
The letter L. The lowercase letter L.
Oh, okay.
Represent levels.
Hello, Seal. Okay. I just thought it was a squiggly line.
It's pretty much a squiggly line, yeah.
So it's definitely then the time it needs to play each level needs to be multiplied by the level, right? So like they all are. That does not exclude anything. Okay. What you're playing? Math. Yeah, fun. I know. And then we add the 5 and the 6 minutes. We don't get those for free. We have to add those to the level time, right? So I don't think
It'd
it's
be nice
3.
if we got them for free.
Huh?
It would be nice if we got them for free.
Yeah, that would be pretty cool if the time only counts that you're in the game. I'm assuming 3 and 4 are not happening because of the minus thingy. That wouldn't make any sense.
Since when has math made sense, though?
The thing is, it makes sense. I'm just not smart enough to understand the sense.
No. This is not a you problem. This is a math problem. You're totally fine.
That's good. That's good. Okay. And that should. If that time that we're doing right, this thing, if it is over the 60 minutes, then we can't get a refund anymore. The trial is
Exactly.
over, so it has to be number 2. Yay!
And then the second part to this question,
Oh god, this is part 2.
there's a part 2. The part 2 is simpler.
Okay.
Do I still have my text settings? I do. What? I just type it. It's faster than going through copy paste.
Can you? Oh god, now I have to do math. Okay, so yeah, I'm just gonna write down the formula. That 3 was bad. Okay, so this is our formula, right? Yeah. Our equation. No wonder I failed my entrance exams. What the hell is the math? I mean, this is still pretty simple math, right? I don't know. I feel like if I started with this, I would probably die, but with all the warm-up we did, I mean, we've been going for 2 hours. This is fine. So
We're on a roll.
and we have L equals 6, because the question is if we can play 6 levels, right? So we have 5 and a 6 plus. Why is the 7 and the 3rd in brackets? That doesn't seem to make any sense.
I think if anything, it was probably just to connect it to the L as a property.
That makes sense.
It's my assumption, at least.
Now that makes sense. This isn't simple. What do you mean? You just put in the number for the thing and then you solve it. It's not algorithm.
All you have to do is the math, and then it's solved.
Just do the math, bro. Just put the 6 into the L, because L equals 6, and then you just do the math. Alright, so 1/3 is basically like 2/6, right? I think that's easier. Oh, no, wait, we have to do the times 6 first. Never mind. What is 7 times 3? 7, 14, 21. So that would be 22. My pen is not writing. 22 thirds times 6 ones. Right?
Mm-hmm.
I don't know if I'm making my life more complicated than it needs to be.
That's a little complex, but you're on the right track.
Yeah. Oh god, 22. I don't think this is the planned way, but I'm gonna commit.
We roll with it.
I'll just roll with it. 22 times 6. 6 times 2 is 12.
We,
And
we
6
might not be rolling the correct direction anymore.
Okay. I thought I'd do this times this. These two and then times that. Okay. I guess we just.
You wanna get your bottom denominator to be matching first?
Oh wait. That doesn't make sense. Because we're multiplying, not adding.
But this guy right here. Do I have my pen on?
Mhm.
This guy right here is representing 6, and this guy right here we just translated from 7. But now if you add them in to make 28, then 28 is
Yeah, but
28
no,
what?
it's not a plus. It's a multiplication.
No, I was saying from what you were doing over here.
Yeah, it was 22 times 6. I was doing that. Like that. And then 6 times 2 is 12. And then 6 times 2 is 12.
Okay, I'm observing.
And we have 132. So 22 times 6 is 132. And then we have 132 thirds.
Does this come out to the correct answer? Hang on.
Listen. I trust my brain. Okay, it's a little more complicated than it needs to be, but I trust it.
You know what? It actually does, though, come out to the correct answer.
See?
Totally different way than I would go about it.
And then we have 5 times 6 to get that into a thingy, right? That's 35, and we have 36. 6. And then we add them. So we have 36 6 plus
36 6 plus 264 6. Oh my gosh. This equation definitely took a turn somewhere.
I believe in my brain. Listen, it might not be the most efficient way, but if it works,
It's one of those trust the process things.
trust the process. That's exactly what I meant when I said trust the process. So, 6 plus 4 is 10. And then we have 4 plus 6 is also 10. 306. Right? And then we need to do 300 divided by 6.
The addition up there's a little bit off.
It is?
Wait.
Is it? No.
You said 36, but you wrote 300. Oh, you meant 300 over 6.
Yeah.
Okay, never mind. Sorry.
Okay. And then we solve this. And 30, that's how many 6 times 35? Wait. Did I fuck up earlier? 5 times 6. I said 35, it's 30. That's wrong.
Where'd you see a 35?
I said it up here. Wait, I made a mistake here. I said 36, but it's 31. Because 5 times 6 is 30, not 35.
Right.
So we have 30. I need to redo the math. I was like, that number is too good to be true. I was like, there's no way. It's just 300 divided by 6. That's too easy. So 1 plus 4 is 5.
That's the terrible thing about math, right? When it's too easy, and you're like, no way, there's no way this is the answer.
Okay, and then we have 295 divided by 6. Right? So 2 divided by 6 is 0. 29 divided by 6 is 6, 12, 18, 24. That's 4. That is 24. That is 5. We pull on the 5. I did it wrong. That is not a number I expected. Wait a sec. 40? Something? No. Okay, it's fine. I will commit. I will commit. That seems, wait, 60 is 6 times 10 is 60. 6 times 9 would be math. What is 6 times? I know math. Wait, 6, 9, 18, 27, 36, 45, 54. That works. Then we have 1 left over. We pull down the 0. Then it just keeps going, I guess.
Pretty much, yeah. From there, just
It's a little
keep
more
going.
than 49.
So what does that 49 represent then?
That is a good question. Oh, then the answer is then 49 something something is smaller than 60. So yes, we can play 6 levels.
Very lopsided star.
Math.
This equation definitely took a turn somewhere.
It worked
But you
out.
ended up at the correct answer.
It worked.
It did work.
My teachers hated me for this, but it kept working.
It kept working, so I just kept doing it.
Yeah. Okay, what was I supposed to be doing? Oh god, okay.
Okay, perfect. Nice. You got it correct though, so
It took way too long. Way too long. Oh my
yeah,
god.
it's okay. It counts.
Whereas
There's
I
no
did the right
difference.
message and still managed to get things wrong. Relatable. Okay.
Okay, so I've got another word problem,
Okay.
and this one actually references you.
Oh,
You are in the word problem.
the alien Bedouin has recruited a human to help them collect cows with their UFO. Their mission will be successful if no less than 2,000 cows will be retrieved. The human, wanting to show their loyalty, managed to collect 178 more cows than Bedouin did. At the end, the mission was a success. Write an inequality to determine the number of cows oh god. that Bedouin could have collected. Okay, wait. So, on one hand, we have me, right? On one hand of the and then we have on the other hand the human.
Mm-hmm.
Right? Gotta go this logic. And then we have some here are more than me, so this is the okay. so this is probably the symbol, right? It's not the number C, the total number of cows, or just the cows that I have collected? Like, is it just C and then C plus 178? No. Yeah. No. Yeah? No? Yeah?
I'm seeing if this is an alternative equation that could technically be true.
I guess it would be more 2C
this,
plus 178 equals 2000.
That's, yeah, okay, so this is the first step. to the answer, and this second step is actually way more closer, but there's something slightly wrong with it.
Huh. I got my answer, it's wrong. We don't know that yet. We don't know that yet. Okay.
It's very close.
Their mission will be successful if no less than... Oh, so... So it could also be more.
Exactly. There you go. That's it.
Math.
And now the next part 2 to this. I mean, I could have just typed this one as well.
What is the solution?
So just like we did with the inequalities before, for like reducing them,
Okay, make it smaller.
make it smaller.
Make it smaller. Okay, so we do minus 178. Then we have 2c is greater than 1. Wait, I can math. 1, 7, 8. Okay, I need to do it like that. Okay, 8 minus 10 is 2. No, 10 minus 8. My brain is working the other way around, but the language does not follow my logic.
I mean, we saw from the last one, the previous one, as long as you get the right answer at the end, we can take some wild turns.
Yeah, that's true. And then we divide that by 2. And then we have the number of cows equals... Okay. And 18, that would be 9. That would be 18. That would be 0. We pull the 2 down. That's 1. That would be 2. That's 0. We pull the 2 down. That's 1. So that's 911. 911 cows. Yay!
Ta-da! Pachi, pachi, pachi.
You know, I'm glad that I wasn't at Newton on birth because I suck ass at math. It's fine, Newton was a physics guy. You still have a chance.
Yeah, all he did was get bonked by apples.
Yeah.
He didn't really do anything about math anyway.
Yeah, he just did some gravity stuff.
So, yeah, that's what I had for inequalities.
Okay. I love how you were scared that we were going through this in like 20 minutes.
Right? Yeah, I thought, oh no, we're just gonna
Like-
breeze through it and then there's gonna be no content.
Yeah, like before we started the stream, like, oh yeah, I just spent 5 hours prepping. I have like 9 pages of work, but like, what if we get it done in 20 minutes? Like, oh, what do we do?
I mean, I didn't want to like underestimate you underestimate you.
I mean, yeah, that's still a lot of work.
Hang on, let me
Been
zoom
at it
back
for
in. I had to
2.5
zoom out. Oh my god, mathing for 2.5 hours.
I'm still fine. I could keep going. Polynomials. What is that? Is that an and?
Yeah.
Oh my god.
There's like a million different ways to write it.
You
Some
don't
people
do
like to do one of
this?
these things.
Yeah, like, huh? Wait,
I like to make
it
like a
this?
backwards 3.
Oh my god, I write it like an 8 and then I do a little triangle, like a little E at the end.
Listen, that's basically like one step removed from doing a treble clef.
I used to do them like that in my music. When I wrote down my music sheets and stuff, I just
Right? That almost looks like an L at that point. Like a cursive L, like a really big
that's
one.
more like an F. I guess it could be
Wait,
an L.
F was like F-lid's like one of those things, or?
I'm writing my F's like this.
Oh, you start at the completely other side.
Oh my god! Wait.
This way?
What's happening again? Yeah, like
Hang on,
yeah.
I go.
I pulled the I draw this line, and then I go up, and then I pull it through. In like
That's
one
so
line.
wild.
Instead of making like 2 lines, I make it 1.
This feels like SpongeBob, where you make a perfect circle by first drawing a really detailed face, and then you erase the details, and then you've got a perfect circle.
Yes, exactly. Okay. Polynomials. Because Meg asked what they are, and I also don't know what they are.
Look at this absolute mess we made.
It doesn't matter. It's the distraction. The ADHD is.
Just move those out of the way.
Just move them there.
So, yeah, we've got monomials and polynomials, and yeah, we've got higher order polynomials like cubic polynomials and things like that.
Mm-hmm.
And what are these? So basically, polynomials and monomials and the other ones, all of those, it's basically just a fancy way to represent yeah, one unit of math that has like some numbers and a letter attached to it. So for example, you might have like 7r. That would be monomial. There's no O there. Monomial. Or you might have like, here, I'll just steal an example. 8p squared.
Mm-hmm.
Plus, I'm just making these up on the spot. 5k. And that would be a polynomial, because then we've got multiple pieces in it.
Mm-hmm.
In general, a polynomial is kind of a type of equation that can continue to chain these, with each section having a certain power associated with it. So you could have, I don't know, like negative 9k 5 plus 8l4 plus 3. We can even skip the 3 if we want and just put a 2. Wait, no, we need a letter here. 3o. Move that guy over there. Minus 2r. This would also be a type of polynomial.
Ah, I see. So basically just a chain of monomials. Monomials.
Basically, yeah.
Monomials.
Mana, do 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 do.
Mono. Do.
Do 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 do. I'm so glad. I'm so happy that you know this also. Oh my gosh.
Oh, classic.
If nothing else, that made this whole stream for me.
Yeah. I feel like our entire cultural exchange was pretty nice.
Right? I'm having a blast right here.
Yeah, dude, I'm learning so much about like American math. So it's just a sentence of numbers.
It's basically a sentence of numbers with each little section associated with a power.
Okay, so like 3 plus 8b would not be a polynomial.
This guy would be a monomial, but overall, yeah, I think technically not. I mean, you could have the 3 over on this side just for standard form of writing it. Like if you ignore this guy.
Yeah.
And then I think, yeah, no, because there's no powers associated with it. So I think technically this still counts as only a monomial inside of an equation.
Okay.
Not technically a polynomial.
Okay.
There are different names for different types of polynomials. And the name is given to the polynomial depending on what is the highest power order that you see inside of it. So if we look at this example here, the highest one inside of here is the 5. And so this one is called a quintic polynomial.
Oh god.
Quintic
I
polynomial. If we had one that only has yeah, if we just have like 2k to the power of 2 minus 3r, this one right here is called a quadratic polynomial.
Mm-hmm.
And then you've got where it's the power of 3 would be a cubic, so on and so forth. There's names for like all of them, and then they follow the kind of like Latin naming convention as they get higher and higher. And polynomials are a piece of math that has a lot of real world scenarios for physics, economics, computer graphics. They're used very often for like curves and Beziers and things like that within computer graphics. But we're just going to look at it from the math side at the moment. Take a sip of water. I'm out of water, actually.
I'm also almost out of water.
How about we take 2 minutes and we go grab some water before we go into polynomials?
Yeah, let's do that.
Sounds good. Then
Okay.
I will move the stream over to the BRB screen for like 2 minutes.
Okay.
See you soon.
Bye-bye. Okay. I have returned. It seems I am still alone. Okay. Got myself some water. I got myself some pizza rolls. Little math snack. Ali isn't here for Nah. Oh, I have like, I googled like, I have never heard polynomials. I googled it during the explanation, and apparently it has the same name in German. It's called Polynome, and I have never heard that before. So I'm just like, wow.
I'm back.
Welcome back. I got myself some cold pizza rolls, so I'll be snacking a
Oh,
bit.
I am so jealous of you right now.
It's like 9 p.m. and I didn't eat yet.
Oh yeah, I'm due for a dinner soon too, actually. But I don't have anything as good as pizza rolls waiting for me.
Too bad. I'm not sure. Okay.
My brain completely emptied of everything we were doing before the break.
Where are we?
Panomino.
Phenomenal.
Okay, let me take a look at my notes. Right, so,
Wrong, Megu. It's 9:30 p.m. Good social not doing math.
9:30 p.m. is the perfect time to do some math.
Yeah, it's like math time. It's international math time.
International math time.
You can Google it. Yeah, my brain might be going a little bit crazy.
I'm feeling it as well. I'm telling you.
I will make up stuff like international math time, so...
You know what? I'm happy to integrate international math time into study streams. That sounds perfect to me, actually.
Amazing.
Like, no lie. Like, I am all for an international math time. Can I even draw parentheses anymore? I feel like an artist trying to draw a circle is just constant stream of undos.
Yeah, basically.
So I'm gonna write an equation. And yeah, now that we identified how polynomials look, I'll explain what standard notation is for them, and then I'll have you work on this equation for me.
Mm-hmm. I'm only a little bit scared.
Perfect. It's still going.
Oh my god.
It's still going.
Oh god.
It's still going.
That's a lot of numbers, man.
It's a lot of numbers.
This might escalate again. I don't know, man.
Monica, thank you for the raid.
Welcome. Welcome, Raiders.
Welcome in, everyone. We are taking a look at polynomials together. We've made a mess of things. This is going to be a lot of names to read out, and welcome all the raiders.
Megu says today is today is Guinea Pig Appreciation Day.
Guinea Pig Appreciation Day. I suppose we can appreciate guinea pigs and math at the same time? Thank you for the follow, D-Rob. And welcome in, raiders. Welcome Nez, Rylan, Cryarch, 4i, Random Guy, Hawu, Monica, Mr. Satan. Monica, no, I love you so much. Yeah, we're doing math.
I'm drawing a guinea pig.
I remember teaching this when I used to tutor math. Yeah, that's a little bit the direction that I'm trying to go a little bit with all of this study streams and things like that. It's going.
It's going.
I definitely have learned that I need a little bit of practice as a teacher, but I'm happy to put in the effort for it, so.
You're a great teacher.
Thank you, I appreciate that.
International Math Day is on March 14th.
Monica, have a good lunch. Enjoy it.
Alright. Is the equation done? Do I add up all the
I did write the equation, yeah.
Okay.
So I wanted to explain standard form. And so, yeah, standard form is a little bit like how I wrote up here, where I surrounded by another color now, blue. This guy. Mm-hmm. Where we basically just have one block each for each of the powers represented. So there's only one block of 5s, there's only one block of 4s, so on and so forth.
Okay.
So it's really about... Polynomials and monomials are really about focusing on the powers.
So we sort.
And what we can do to simplify this is we can combine like terms, and we don't have to do too much crazy other than that. So no pressure.
Wait, I think I remember this.
There is one or two little gotchas though when combining like terms.
Is it this thing where I do this?
I mean, essentially you'll do that, but you won't do it with multiplication.
Yeah. And then I write it down in a really long line. Yeah. Okay.
Yeah.
So we have -2. Oh god. Wait. My brain needs to load. Get back into math. The break was too long. Do I just do this? My pen is refusing to write. Right? And then... What? Wait, no. Wait. Ah! my pen refuses to cooperate. And then we do this again. Where did the numbers go?
Where did the numbers go?
Where did the numbers go? Why is it refusing to write the number? I'm gonna zoom in. We're zooming in. Okay.
We're getting close.
And then I do it again, and then but like plus 3k, and then I do minus like this. Wait, no. Like that. I don't know if I'm on the right track. I can't see the equation anymore.
Question came up in chat if k means 2000. In this case, no. We're using k just as a plain variable. Has no special meaning otherwise.
Plus 5.
Oh, I gotta zoom out a little bit.
Am I like... Am I doing something completely wrong? Do tell me, please.
It is a little bit more expanded than it should be.
Okay.
We've got a lot of terms here.
Yeah, and I was gonna sum them up now. Okay, more expanded than it should be means wrong, or...
I mean, I would have to see if this is another one of those roundabout ways equals the correct answer sort of thing. It's definitely more expanded than I would have done. But maybe after you combine it, you get the right answer. I don't know.
Okay. So we have this one and this one for the 3.
Yeah, there was a question in chat of where this one came from.
Because I did this and then I did this.
That would be incorrect at that point.
Then I did everything wrong.
Oh no!
Okay. I don't know how to do this.
Okay, no worries. This first one is a little bit less complicated than maybe we were getting into it. We can really just take a look at the exponents here, whether or not they have an exponent or not, for each of these 5 terms, and then just combine the similar ones. And so this one right here is already complete because we don't have a cubed anywhere else. These two, ooh, that was a very shaky line. These two will get combined.
Yeah.
And these two will get combined.
But like...
And that's all you have to do for those there.
Right. These things.
Those you can basically ignore for purposes of simplifying polynomials. Those kind of just disappear during these kind of things.
You just tricked me, huh?
It's because we're adding at this point.
Oh, that makes sense. Okay. So I just do this. My pen just... Miro does not like me drawing small numbers. And then, yeah, -7 plus 6 is -1. And then plus 8. Okay.
One thing you could also do in addition is 1k. You could simplify to just be
Fair enough. Yeah, yeah.
that.
True, true, true.
But you got it correct.
Yay.
I've got another one of these.
Mm-hmm.
Got minus 5k. Oh, that's a little too far away. Minus 5k to the power of 3. Minus 6k. Plus 1.
Mm-hmm.
Plus. Minus 6k squared. Plus 5k.
Mm-hmm.
Did I copy this correctly? I think so. Yep, that's it.
Okay. Hmm.
The equation's so long I have to look back and forth to my notes like 3 times. I can feel the tension in your
Yeah, there's truly tension.
oh no, is this correct?
The longer the wait is, then I get anxious. I'm like,
Right?
are you waiting for me to correct myself? And then it's like, but it was fine in the end.
Squared minus 7r. Yeah, you had it, no problem. I have every confidence in you.
Thank you, thank you.
I mean, after these 3 hours of math that we've been through, we're like war buddies now.
Yeah. Little math buddies. Meaning for lunch to do math.
Oh, I'm going uphill again. There we go.
Don't worry.
That's a 9, by the way.
Oh, it's not a Q?
No, that's not a Q this time.
Okay. So you got 7r squared. Because 8 minus 1, right? Trying to talk a bit while doing it so people can follow my brain. I got negative 7 plus 1, which is negative 6r. Alright, now we've got minus 9. Yay!
Yeah, simplifying polynomials is once you kind of recognize the whole thing about groups of powers.
Yeah.
This stuff is pretty easy.
Yeah, I don't think I did this in school. That's why I was really confused.
I think my classes touched on it very, very briefly.
Like,
but it was like we immediately went into like factorization.
Yeah, I think that's also what we did. Like, I've
Factorization, like the x plus 2,
like, yeah,
and then like y plus 4. This sort of weird factorization where you had to like do the first things, and then the outside things, and then the inside things, and then
That's
the
how you
last
write it?
things.
What? Oh my god!
I mean, we don't write it with lines like this. We use an acronym. We say FOIL.
FOIL? Okay.
First, outside, inside, last.
Oh, we just keep drawing these tiny lines. We do this first, then this, then this.
Yeah, we do that too. Ignore my mess down here.
I was so confused. Like, is that another American?
Yeah, no, that's a Helvy thing.
That's a Helvy thing. Okay.
That's a Helvy thing. Ignore me.
Don't worry. It's like your Q9. It's okay.
Yeah, exactly.
It's nice. You picked this up so much faster than I ever did. I mean, for one, I had most of the stuff at some point before. And I don't know, I guess math was never that difficult to me. I don't know. I feel like it was one of the few subjects where I was not bored in class just listening to a teacher, but I could use my brain, right? I could sit there and do brain stuff.
Yeah, I was the type of student who is always. I didn't have challenge in the other classes, and math was something that actually gave me a little bit of a challenge for the hard stuff. And so then with my ADHD brain, it was immediately more interesting. It was also like a puzzle, and I mean, I'm really into puzzles, so.
I think it also feels more like learning something than just a teacher talking about history, and you're like, okay, I guess that's stuff that happened. When
History was the
when you
worst.
learn new math stuff, you have this, oh my god, I know something more now. You have it in front of you.
Exactly. And history was just like memorizing lists of years and people's names. And I have a problem memorizing people's names in general. How am I going to do it for a class?
I can't memorize years. I can't memorize people, and that was like 90% of the grade. And I was like, great.
Yeah.
Great.
Oh, it's awful.
Lost cause. I enjoyed English a lot more too. I failed so many language classes because they taught so weird things.
Did they also teach your foreign language classes like really slowly? Like by the end of the semester, all you could do was like say, hello, how are you?
I currently done with the main education, and I'm like learning how to be a graphic designer, and we also have English classes there, right? In 13th grade, to graduate, I wrote a 8-page exam essay on this 4-page newspaper article. My current English classes legit had the task, write a 50-word essay. That's like 5 sentences.
Yeah, I was going to say 50-word.
Yeah.
Is that even an essay at that point?
Yeah, at that point, you're just right. Yeah, I'm going to talk about horses. I think horses are pretty cool. That was my essay about horses.
You're basically sending an SMS at that point.
Yeah, it's literally like, I write Discord messages that are longer.
Right? I think I've written more crazy things about math today.
That is a tweet that's like not even a tweet. That's the thing.
Oh my god.
And a lot of people did not. It's insane how I don't know. I was like in the advanced English class. It's amazing that there's like adults out there who had English in schools all their life, and that's like the level. I don't know. It's kind of
no,
because English is like I suck at Spanish because I have no use for Spanish, so I only learned like hi, my name is.
Right, it's one of those things that you have to actually.
English is like you kind of need
like
it.
have a use for it.
Yeah.
Exactly. Yeah. I mean that's why it's lingua franca. Is that how they call it? Lingua franca?
I don't know.
It's one of those things. The fancy word that means like the general accepted daily use language for miscellaneous things.
Now I can do the multiplication thing though, right?
Yeah, we're gonna do some multiplying of polynomials now. Yay. And whereas with the addition, we could kind of just combine like terms and call it a day. With this guy, we actually do have to do the distribution property to get the outside term into the inside terms. But in doing so, there is a little bit of a gotcha. And I think it would probably be fair if I mention it first. So we've got, let me check my notes. That way I can explain it how I wrote it down. Okay, so let me write another example actually. Okay, I'm already going to write down the second equation, so we have 2 of them ready to go. Because the second one shows one of the things I want to explain.
Okay.
Minus n squared. N squared plus 5n plus 6 coming out of lurking and say that my high school gave us quadrix formula on first day and 3 sheets of equations to solve on our own. Then I just got it, but the number of application only at my school. Yeah, you don't really use this. I mean, you do in like some scientific disciplines. If you're doing something with physics or with actual programming code that has to do with like rendering graphics or so, but the amount of people that are actually going to use it on a day-to-day excursion is very, very few.
Mm.
So it's not, yeah, I would agree it's not that useful to actually learn, but yeah, it's part of math. I mean, there will be other portions. That's one thing about math, right? Is that every time you learn about some portion of math, some other portion of math is going to want you to use it inside of that as like a little nested egg inside. So I'm not aware of which disciplines of math want you to use multiplication of polynomials, but I could look it up one day and I'm sure I would find out and then want to learn that discipline of math as well. I actually have some math books on my library behind me. I want to learn combinatorics. That's always been one of my favorite studies of math.
I have no idea what that is.
It's the mathematical discipline of counting.
Of counting.
And so the one example that I always give, although the examples in the math book I have are like, I can't actually even start into this math book because it's more complex than I have an understanding for it to go with. But one example that I like to give is, let's say you have like a combination lock, right?
Mm-hmm.
And you've got
Wait.
4 slots here
Yeah.
for this combination lock.
Yeah.
Nice. What is the total number of combinations that is possible if each of the wheels can have a digit 0 through 9?
I had that in class. Oh my god, wait. I do not remember. Wait, I definitely had that though. Wait. I think it was on my final exam. Is it this? Is it that simple?
What is that symbol?
It's a 9.
It is not a 9.
No.
Nope.
Okay.
No.
I don't know. It was I definitely did that. My brain will not remember.
Since the set of 0 through 9 is 10 different digits and you have 4 slots here,
I forgot the 0.
10 to the power of 4, which
forgot.
equals 10,000 combinations, which then makes sense if you could have if you could count all the way up to 9999, but then also have 0, 0, 0, 0 as a possible combination. So it's 10,000.
I kind of just switched the numbers. I forgot 0 was a number.
Right, yeah, I thought you were going in that direction.
Yeah, okay. Also, hi SP, thank you for the resub. How you doing? 11 months. Wowie.
You can also kind of like bring this a little bit more advanced if you think of like hexadecimal, for example, which is then like base 16. So you've got 0 through 9, but then also A, B, C, D, E,
yes, I
F.
had that. Oh my god. That was so much fun.
I love hexadecimal. It's great.
Yeah.
But if you had these for the combination lock up here, then you'd have 16 possible values for each of these, but still 4 slots. And so it would instead be 16 to the power of 4.
Yeah.
Which I'm going to use a calculator for that. 16 to the power of 4. Yeah, exactly. 65536.
I actually remember when I had that in class. We didn't have that with numbers. We had that with every symbol of the alphabet, right? And I forgot the alphabet has 26 letters. I just wrote 24.
Oops.
I remember that moment.
Oops.
Because I was so confused. I was like, "Huh? What do you mean 26?" So that stuck to my head. Yeah.
That's unfortunate.
Poor memory.
Core memories like that are the worst.
And yet I'm still sharing it with the internet. Okay, so
that's combinatorics, at least over there on that other side. combinatorics.
Yay.
Fortuna says, I used polynomials to visualize what does time stop look like with vectors. Too wee back then since teacher had no clue what I was cooking. Yeah. Yeah, it's one of those. It's one of these things that you can really integrate into like some kind of physics or something like that. It's a little bit over my head. Like this right here, what we're doing here is kind of my limit of polynomial knowledge. I do know a couple of other small things that you can start to do with them, but then I reach my limit with this direction at least.
I see.
So yeah, when we're distributing these guys, you may come across sometimes. Here, let me change to my blue. One of these guys right here, like this unit, where he doesn't have a power associated with it. It's just 5n. But for the purpose of distribution, and this is just how I imagined it as I was learning it, is that you can kind of imagine there's not an arrow, but rather a 1. I don't know why I drew an arrow. You can kind of imagine a 1 there in terms of what we're going to do with the exponent here. When you multiply an exponent like this from an outside portion into the inner portions, the exponents add together.
Oh.
And so right here, the 2 and the 2, when you bring these two together, will end up being n4. And because we imagine the 1 on this guy, then 2 plus 1 will be the 5 and 3, so on and so forth. So let's, with that said, yeah, the idea is that we want to distribute the outside terms to the inside terms to, simplify the equation. And let's start with this first one up here.
Okay. So this is like a 1. So we have negative
I'll move this guy down.
4. Like that. No.
Keep in mind that the multiplication, the negatives.
I realized. This one is minus 8. Like that.
Exactly. Yep.
Exactly. So you do 1 plus 3 and then 1 plus 2. Okay.
So at the end, when we distribute this guy, we get 4t to the power of 4 minus 8t to the power of 3.
Okay.
So now we can come back. Oops. Now we can come back to this guy, and I'll go ahead and remove some of the markings that we did. I'll remove these guys as well, so we don't get confused by anything. And go ahead and do that one as well.
Okay. Like that. I gotta mock you. Where did he go? Did I get him? I don't see him anymore. Okay.
Did you say it was a moth?
A moth.
A moth.
A moth.
Mothman. Mothman. Mothman came to learn math.
Yeah, exactly.
Mathman.
Mathman.
Double checking my notes back and forth. There's one part here with these two. These two also end up absorbing some of the outside term.
So I just add the n2 there too.
Exactly.
Just a pretty 2 maybe.
That's a capital L. There we go.
I'm trying.
We got there in the end. Okay, so yeah, we've already got 2 down.
Let's go. Okay.
These ones, I feel like these ones kind of follow a pattern, and like you don't really have to do anything super, super crazy with them.
I mean, it's basically simple addition.
Exactly. Plus 25. Yeah, that one's ready.
Okay. Bam.
Exactly. Yeah, we're gonna be through these in no problem at all. Do I even have any kind of like? I don't even have any ones that should trip you up in here, I think.
That's because you can strip me up.
Oh, I
Will
should have known.
Will I regret saying that in 5 seconds? We will find out.
That one's good to go.
Okay. I see. So
Have a good night, Oliver. See you next time. Also, hi Zoid. Welcome in. You napped for forever and ever. Is Phoebe still asleep?
just woke up and is having breakfast.
Breakfast, num num num, as a
Yum, yum,
classic
yum.
Phoebe does. This one is not quite correct.
Okay.
We have a problem with this section, and we have a problem
Is it the
with this section.
oh. Well, I did regret what I was saying. As it was foretold. Wait. But like this is a 1, right? On top of here.
Yeah. That essentially is like a 1.
So we have this plus 1 there. So it's this plus 3. Or is it
Yeah,
this
this
a
part.
plus? Is that the issue?
Exactly, yeah. The 3 is fine, but we're positive now because we distribute the negative into the negative.
So then this is no, this is also positive. How did I do it right one time and wrong the other time? And this one.
This one, I see why you do this one wrong, but the previous one correct. Because this one actually has like it's not necessarily a gotcha, but it's a point that I didn't explain about it. Yeah, you basically are doing the proper multiplication when you get to the numbers here. So in the previous example, we were able to just turn 6 into 6n squared. But with this one, we're actually kind of like multiplying the -5 and the -5. And so this section right here ends up being a plus 25 q squared.
That makes... Okay. I think my brain is starting to not work anymore because that was so obvious.
It's a part that I didn't explain though, so it's on me.
I mean, it makes like this is a little multiplication right here, right?
Yeah,
So
that is a little multiplication.
I don't know why I added it.
Yeah, it's okay. It's okay, no worries.
I even did the plus.
You did do the... Wait, no, you had that minus at first.
Did I? No, I had this one minus.
For the first version? I thought you had them both
no, I
minus
think I had...
first.
I know, I had... I had minus and then plus, which is why I was like, why did I do one plus and the other not? It's fine. It's 10 p.m. I'm allowed to. My math brain stopped working.
I actually do have a whole extra section after polynomials. You can let me know when we reach that if you want to start into it.
We can keep going. I am
Okay.
not weak. Yeah, I'm good.
Yeah, okay.
I'm
cool.
just tired, so I make a little. I'll make more mistakes, but I'm still good.
Mistakes are perfectly fine. Mistakes are part of learning.
Mm-hmm. Exactly.
So if we fix this guy up, what do we have as the correct final equation then?
5. This. That's a 3. Plus.
Perfect.
Yay!
Nice.
Okay. Canvas is getting really, really long. Oh, well, we stopped going to the right.
That's true. But actually, I'm writing upwards now again. For
Fine.
some reason.
Don't worry about it.
I even have grid lines on this board that I can use to follow, but I just don't.
I noticed. It's fine.
3x multiplied by the product of x squared minus 5x plus 6.
So then we have 3x. 3. Minus 15x squared. 6 times 3. I don't know numbers. Wait. 6, 12, 18. Yay! Okay.
Easy peasy.
Easy peasy lemon squeezy.
Lemon squeezy.
Yeah.
See, this is how my original idea of the stream was going to be, that I was just going to write an equation and you're just going to whip out the answer. And then we're done in 20 minutes.
Yeah. I think even if we did speedrun it, it wouldn't have been 20 minutes. Okay.
I'm very bad at estimating things.
Fine. So am I. No. Wait. Oh, it's a minus. It's a minus. 25 times 3 is 75. 8. Yay! Hi, and fame. I got a question. Does it ever get tiring? Well, we're 3 hours in, and it hasn't been... Oh, I thought...
Hello?
Oh, that was so smooth. No way, I was mid-sentence. Oh my god.
Oh no, you got caught out. You got so caught
I
out.
fell right for it. Oh my god. Thank you very much. Oh, that one got me. Can I rate you? Rate me as in what? Like from 1 to 10? I guess, sure. I can't stop you.
Between Oogle and Boogle?
On a pH scale of 1 to 14, I'd say you're a 1 because your acidic beauty melts my heart away.
Oh my gosh.
Oh my goodness.
No.
Oh god.
I have to give that pickup line a pH of 14 because it's so basic.
That threw me. I'm not used to getting hit on, so this is just more funny to me. I'm sorry. My brain was like, you know,
this is your brain.
You know when
this
people,
is your brain on math.
You know when people in school try to like fake flirt with you to make fun of you for thinking it's real or something.
Yeah.
Yeah, that was what my brain is immediately suggesting every single attempt at flirting towards you.
That's trauma, babe.
Trauma.
Oh
the
no.
good kind. Oh wait, this is. Wait, this is not 2p. This is p and a little 4. Right? Yeah, my brain did not stop working. Wait. 2. No. Yes. Yes.
I felt you cooking on that one.
I was like, wait, yeah. I don't know if you can like tell, but like the plus and the minus thingies, those were like
Yeah.
every single mistake I made.
Oh
during my
no.
every time I made a mistake was one of those. I haven't learned it. You like put a
That's
smile on your face. Not gonna lie, your smile is the sweetest. Ah, humma. Thank you.
Humma.
Humma.
The things that happen in the just chatting category, I'm telling you.
It do be. You know what? Things that would have happened today while doing math for over 3 hours. Getting hit on was not on my list of expectations. Okay, math. M for math. That's negative M high 4. Plus
Almost a
M.
high five.
Almost a
Not
high
quite.
5.
M for that's correct.
I don't know. Bro. Why did you do me like that? I saw my life flash before my eyes. I checked the minuses again.
No, what is Helmy saying? No, I checked them.
No, what? Am I stupid?
Drop B anymore. Oh my gosh, I feel like it's getting late.
Oh, a little bit. And for Minecraft, you like Minecraft? Everyone likes Minecraft.
Oh, I love Minecraft.
Yeah, I feel like you'd be the odd one out for not liking Minecraft.
Right?
Yeah, like who does not?
I still need to build a proper house on the server at some
It's
point.
a high 5.
Now it's a high 5.
Yeah. 8, 6, 32.
Congratulations, you passed all of the equations I had for monomials and polynomials.
Go! Whoa!
Wow.
Wow!
Okay, I've just got one more short section. It's funny, I actually wanted to prepare even more after this, because this then starts to go into geometry. And I had like a whole plan of like, oh, I want to teach these geometric concepts, and like,
I love geometry.
I love geometry too. I have to spell it correctly. Geometry. Okay, yeah.
When you said it slowly, I thought you spelled it wrong. Anyway, oh my god.
Yeah, that would be something I would do.
Just geometry. Oh yeah, it's correct. Like, if I was like, it is correct. Geometry.
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 Geometry. And we're going to take a look at
Thanks for the hired flute.
lines.
Lines.
The most basic, it's not even a shape, the most basic thing of, actually no, I guess a point is even more basic. Let's talk about points. Exactly. Perfect. Oh, I didn't do a point.
Oh, that's not a point.
No, I was making a line.
That was a lie.
Perfect. Oh, that one smudged as well. Oh, this is such a delicate operation here. There we go. So, a point is, yeah, it has no size, it has no dimension. It's simply a dot to identify a location in space. But yeah, it has no size, it has no dimension, so it has no weight to it. It simply is a spot, and that's it.
Nice.
If we have like a standard kind of x-axis and y-axis sort of thing, where we had like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Exactly. Thank you. And we just have like this little guy hanging out right here. That would be represented as 3, 3.
That's more like 2.5.
Who's counting? I'm not counting. Are you counting? Is this counting class? That one's pretty on, right? You're not telling me the Y is not
maybe
pretty
my
on.
line is just not.
I mean, this line is also
it's
like it's going down,
2.75 maybe.
Okay,
like
okay, we can cross this guy out. We can say
like
2.75.
Yeah.
Perfect. What the heck?
This is getting unhinged. Oh my god. No.
Meanwhile, this is a point, but then we can also have a line, and a line will just be, yeah, exactly. Perfect. You already know what you're doing.
I know what a line is. Oh my god.
Except the addition that lines, when speaking of lines, like as a specific thing, they also get these arrowheads on them to show that they extend infinitely in both directions.
Wait, I gotta Google something.
You can have a version of line with points at the ends.
Yeah, I was gonna say, wait.
Yeah, I know exactly what you were gonna say.
Wait.
We can put a point here, and we can put a point here.
And then there was lines that are only infinite in one direction.
Yeah. Okay, if they're infinite in a direction, then they get the arrowhead. Let's say it that way.
Oh yeah, okay. The one with the 2 dots, it's called a path.
Yeah.
Exactly. At least in German. In German, at least.
I think we would call it a line segment in English, maybe.
Oui.
Because the line is the infinite one, and the segment of the line is the one with points. It's terminated. Maybe. Don't quote me on that. Unless it's correct, then do quote me on it.
Okay. It's really funny. By the way, fun fact, German fact. This infinite line, right? This thing. In Germany, we just call that a straight.
Why is it straight?
Because it's a straight line, so it's just a straight.
I don't know about Germany.
It's a gerade, which just means straight.
I'm gonna start drawing all of my lines like this now.
Oh, that's a curve.
We can just estimate. It's pretty much like this, right?
Yeah.
Close enough. There's a whole math discipline that we could study about that is all about estimating and getting just close enough values. Like I wanted to go into statistics actually as well. That was another thing that I had kind of like planned, like with significant figures and what else did I write down? I wrote standard deviation, R values, like there's a whole nother section here that we could have gone into.
Ooh.
For now, we're going to take a look at points and we're going to and lines. We're going to take a look at addition of line segments. And so if we have, for example, I'm using the grid to line this up, but it may not be to scale. Let me get another color. Let me get this, I guess. Oh, I'm trying my best to draw a straight line, and this is not working.
There is a line tool, by the way.
Yeah, but who's going to use the line tool? So we've got a line here with 3 points. And we're going to label these points. We're going to label them...
ABC.
Yeah, we're going to label them ABC, because that fits exactly with the equation that I wrote down that we're going to solve.
Oh, perfect.
So, yeah, we are saying that B is the midpoint between A and C. And yeah, from here, we just have a little mathematical equation. We are going to say that AB, we'll put the line above it, and that represents, yeah, the line that matches the two endpoints A and B, like the line segment that connects them. I'm going to say AB is equal to, that's a terrible 8, 8x plus 3. And we're going to say that BC is equal to 2x plus 51. Find AC.
Oh no, wait, no, AC. Bro. I didn't read the question.
ACBC?
AC equals AB plus BC. So that is 8x plus 3 plus 2x plus 51. So that would be 10x plus 54.
That is a, how do I want to say,
I'm doing it wrong,
a complex version of the equation, but we can actually simplify the answer down to just a single number. We have all the information we need for it. Do you want a hint?
Is this a B equals BC thing?
Yeah. Because B is the midpoint.
Yeah, that makes sense. Yeah. Okay, so 8x plus 3 equals 2x plus 51. So we do minus 3. 8x equals 2x plus 48. Oh god, this is gonna go wrong again. Wait, no, okay. Should I rather move? I think moving the number to the other side is smarter. Doing minus 51. then divided by 2. Wait, no, that doesn't make sense. Wait. I know how to solve this. I just logic. Wait, I need to think about this. And now we do minus 2x.
There you go.
There we go.
There you go. That makes it easier.
That makes it easier. Here we go. Oh yeah, now we okay, and then we divide it by 6. X equals eh? Okay, wait. 6, 12, 18, 24, 30, 36, 40, 42, 48. That is 8. That is 8.
Mm-hmm.
Uh-huh.
And now what can we do with this?
We put this into 8 times 8 plus 3.
Yep.
8. Oh, I got 8 times 8. That is 64. I need to do that in German. Plus 3.
Oh, good.
4, 5, 6, 7. That's 67. Times 2, because that is only half of the way, is a very high number. That is... Okay, 2 times 7 is 14. 2 times 6... Wait, no, I need to write it down. Differently. My brain does not function. Okay, we do this. Times 2. That is 14. And 2 times 6 is 12. Oh, we do 60, so there's a 0. So we have 114. No, 43. 34. 134.
You get an extra gold star, by the way,
Why?
for this part right here.
Oh.
Because dummy me, as I was solving these practice equations beforehand, I actually did both equations and added them together.
Oh!
Because it's the midpoint, you can just multiply by 2.
Oh, yeah, because of this, right?
Yeah. I actually did both equations. I substituted x in both of them.
I see. I mean, yeah, you can do that.
I mean, it works, right?
Yeah.
By the way, I love that we're totally going down on this angle again now.
It's fine. It's fine. This is already an endlessly long paper.
Right? Wait, let's zoom out again. What does it look like now?
Probably terrible. Oh, that's a lot of...
Oh my gosh.
That's a lot of math.
I mean, we started going straight down for a while at some point. Probably when you pointed it out, I think.
Yeah.
When you drew the crocodile or the alligator?
Hmm. Wow.
I think I have to save this as like a PNG or a PDF later or something.
It's gonna be so...
It'll be like 25 megabytes or more.
Just all the random crossed out stuff and doodles that are unrelated. And our entire us drawing Fs.
Oh my gosh.
Yes, that's beautiful. Okay.
Okay, apparently I went a little wild with the other examples, then I started using other letters, but we're just going to stick with ABC. So we've got the same principle as before.
Still calculating? Yes.
AB 8x plus 3.
Mm-hmm.
BC. Wait, no, we just did this one.
I was like, this looks familiar.
We just did this one. Hang on. I'm in the wrong spot. 2x minus 1 and 8x plus 43.
Mm-hmm. Find AC.
Find AC.
Okay, so we do the same stuff again. 2x
Same deal.
minus 1 equals 8x plus 4, 3. I just made the 3 ugly. Okay. So we do plus 1. So we have 2x equals 8x plus 44. And we do minus 8x. That is negative 6x equals 44. And we do divided by negative.
I noticed myself starting to turn my head.
I also. I'm sorry. Wait. Can I fix this? Wait. Can I mark something that is not just a straight square?
You would hope so, or?
Yeah. I can't find it.
Is there no...
Oh yeah, wait. I will just move it down first.
There's no lasso tool. What the world?
Really? Okay. Maybe this. This looks even worse now.
Yeah. Oh
This is-
no.
Wait, maybe if we turn this a little bit more. Maybe this is fine.
There we
right?
go.
Yeah,
There we go.
There we go. Yeah, and then we have x equals, okay, 6 again. 6, 12, 18, 24, 30, 36, 42. That doesn't add up. Wait a second. Okay, it's 7. Ah, what the fuck?
Oh, where did that come from?
It's 7 and a third, according to Google, because I'm a cheater. I am. Oh my god. So, and we put that into the equation. So we have, oh my, 2 times 7 and a third minus 1 equals 2 times 7 is 14. And that would be 14 and 2/3. Why am I not writing anymore? 14 and 2/3 and then minus 1. So I feel like I'm wrong. I feel like this is not the answer I'm supposed to be having.
I do have a different answer than you, and I'm trying to follow the chain to see where we deviated.
Yeah. Okay, wait, let's go back to the... Yeah, but I think... Hey?
Hi, Wendy. Thank you for the follow.
I don't get it. Like, okay, I obviously have it wrong.
Let me take a little doodle. Where did we deviate in this?
Okay, like, okay, this
Do I
is
have an error in my
minus
notes?
7. I think, but that doesn't change stuff.
I have x equaling...
Wait, I'm just gonna try this again. Okay, let's do minus 3 here. So the other way around. Then we have 2x minus 44 equals 8x. And then we do minus 2x. Then we have, yeah, then we have negative 44 equals 6x. And then we divide by 6. And then we have the weird number again, because 44 does not divide by 6 properly.
Hang on a second. What?
What?
2x minus 1 plus 43.
Did you copy them?
Yeah, exactly. I might have copied something wrong, maybe?
If it would be like, wait, if it's like... If it wasn't a 3 but a 9, if it was 49, maybe. 49 minus 1 is 48, and that would give x equals 8.
If x equals 8, does that fit in with what I have here?
Because I feel like you could misread 9 as a 3.
One moment.
Mm-hmm.
I need to write this down to actually see if this is if this is the error I made. And then we're just gonna swap a bunch of this around. I did it the roundabout way.
Okay, but why do you have minus 72? And minus 40... Oh, wait. Eh? Yeah. Oh, wait.
Yeah, the error was on my fault. It's not actually plus 43, it's minus 43. And that completely breaks the equation.
Okay,
It
so...
turns the line into a negative nothingness.
That wasn't my fault. Okay. So x is 7. That would make it a lot easier.
Yeah. Oops, my bad.
So then we have 2 times 7 minus 1. That would be
Hi, Aika. Welcome in.
13, and 13 times 2 would be 26.
And that's the answer I have in my notes.
Yay!
Yay! Oh my gosh.
Oh.
You caught me at the perfect time, Aika. I completely had an error in my teacher's notes and gave a completely wrong equation. And we completely went down a rabbit hole.
Well, but we did it. We found it. It's okay.
I appreciate putting up with me.
I'll be in a bit. Okay, okay. Okay.
Okay, let's hope that these other ones don't have the same thing going on. 6x plus 2. Five x plus 3.
AC equals question mark. Okay, so we have 6x plus 2 equals 5x plus 3. So we do minus 2. And we get 6x equals 5x plus 1. And we do minus 5x. And we get x equals 1. And we put that in. 6 times 1 is 1. 6,
I'm sorry, what?
6 times 1 is 6. Plus 2 is 8. So the answer is 16.
Okay, one last one for line segments.
Okay.
We've got AB is, where are we? Make sure I write the correct thing. BC is 5x minus 3. BC is question mark.
Plus 3. So we do that. We have 6x minus 4. 5, 6, yeah. I did the 7 without thinking too long.
I'm proud of you.
Progress! Minus 6x. I feel like I should have maybe done it the other way around.
Yeah, then you'll end up like the situation I did where
We
you
could
end up
just
having a 0
multiply.
on one side.
We could just multiply times minus 1. It's okay. Equals negative x. And then we do times negative 1. And then we have 4 equals x. So 5 times 4 equals 20. Minus 3 is 17. 30. No. Wait. 17 times 2. Times 2. That's your mouth curse. And 2 times 1 is 2. 20. 34.
That was amazing.
I love doubting myself. I'm also running curved again.
Yeah, we're going curved again.
It's fine. It's fine. I'm getting tired.
I would say that's probably perfect timing then, if we're starting to get a little bit silly and tired. I have information written down on angles, but I didn't actually come up with any equations for them or anything like that. So we can probably save the rest of geometry for maybe next time if we do this again.
Sure, definitely.
If you would like to.
I definitely love to.
Nice.
I love doing math with you.
Yeah? Good.
Yeah.
I'm glad.
Yeah,
That makes me happy.
I really did.
I feel really good to actually get into study today and like plan it out and all. Like one thing I discovered, I have a whole newfound appreciation for teachers that actually have to create these lessons plans like very often by hand and things. It took so much brain juice to put all of these things together. Yeah. And even still, I made mistakes.
It happens.
It happens.
I feel like definitely the first time teachers do it, it's hell. I think that's why all teachers just reuse the same plan every year.
That makes sense. I mean, I'm definitely keeping all of these notes that I took, not only in the lesson plan, but also I want to keep a copy of what we drew here today.
Yeah. We can just continue here next time.
You know what? Actually, that could be really cool. Then we can have like this, we can build it into like this kind of Helvy Berry lore board sort of thing.
Lore board. It's just.
And we can reflect back on days gone past.
That would be pretty cool.
I like that.
I also like that.
Nice. Yeah, and we have to go into these guys next time too with the angles.
Yeah.
These guys are fun. I like doing these.
I also really like doing them.
Nice. And then I can include some of these Professor Layton style ones too.
Oy. Yeah, break my brain. Just have no
Exactly.
honestly have no mercy on me.
Perfect. Then that means I already have a plan of what we can do for next math stream.
The worst that can happen is that I learn from my mistakes. There's no downside.
Wait, why is that the worst? Isn't that the best?
Yeah, but that's like even if you overpower my brain, the only thing that happens is that I learn. So it doesn't matter if you completely
Ah, I see where you're going with this. That makes sense.
like in any case, I'm learning. So it's all either way, it's a good outcome.
Yeah, it's all valuable.
Yeah.
It's all valuable.
All right. I'm actually about to fall asleep.
Right? We need to eat something too. We didn't
Yeah,
eat yet.
definitely.
I mean, you had your pizza rolls.
Yeah,
but
I have pizza rolls. Oh, it's
do you
like,
have a suggestion on who we might be able to raid?
I did not look at anything yet. I don't usually
If
raid
not, I
people.
do. But
Sure, I don't mind.
okay. Then I will write you the name on Discord. Let me check their stream first to see what they're up to.
Raid Shadow Ledge.
Raid Shadow Legends. Yeah, that audio probably came through on my stream since I think I'm capturing all desktop audio, but that's fine. Yeah. Where are you? There you are. So, yeah, this is an artist that I really like to watch. I like to see some of their art that they're making.
Mhm.
They recently started streaming, as in like 2 weeks ago or something like that. But I've been hanging out in all of their streams, and they're always happy to see me, and they're having a good time. At the moment, they're playing Yakuza 0. So completely different energy than what we've been doing here tonight, but
I think people
that's
need
fine
that
too. Yeah, that's actually, yeah. People need to have a break from, how long have we been going now? 4 hours of math.
4 hours of math.
Oh, how could I put us both through this?
I would do it again with no hesitation.
That makes me happy to hear. Good, I'm
No,
glad.
honestly, doing math with you was like so much fun. Like for real.
Then we definitely have to write later and plan the next one because I'm ready for a next one.
Oh,
I
yeah.
actually had a ton of fun.
Yeah, definitely. That
Nice.
was a lot more fun than I expected.
I'm glad. That actually legit makes me really happy. I was hoping it was going to at least be entertaining and that there was going to be good vibes, but it turned out even better than I could expect.
Yay. Alrighty.
So thank you to everybody who stopped by. Thank you for the new follows. Thank you for Monica for the raid. Absolutely. I think you're off having lunch by now. But thank you for everybody checking out Math Studies with Bettery and me. And yeah, at least from my side, hope to see you again next time.
Definitely. Yay.
Any final notes from your side, Bettery, before we start the raid? Or have you already started?
The alien is EP. I've already started.
Perfect.
The alien
then
is
I
EP.
will...
She will go take a nap.
The missile is EP.
Very EP.
Okay. Then hope to see everybody in the raid. We're going to visit this artist that I like. Their name is Tivi, Tivi. Give them a nice warm greeting. Don't cause trouble.
Yeah, behave.
And yeah.
Yeah. Bye-bye.
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 See you next time.